Hi guys, Daniel here. Hope you're doing well. Hope you guys are studying hard. So today we've got the A-level Maths Edexcel paper 2 of the June 2023 series. So having doing this paper, definitely thought there was a couple of tricky questions in there, but overall not too bad, pretty standard. And yeah, again, you guys will have the timestamps in the description, so you can just easily go to whatever question you like or a specific part of a question. And hopefully this isn't uploaded too long after I've uploaded paper 1. If you haven't watched that, I'll put a link in the description for that as well. And yeah, that's pretty much it really from me. Let's get into it. Okay, so question 1 says f of x is equal to x cubed plus 2x squared minus 8x plus 5. And part A says we need to find f double dash of x for 2 marks. Okay, that just means we need to differentiate twice, which is not bad. So I'm going to write it out again. Got f of x is equal to x cubed plus 2x squared minus 8x plus 5. Okay, now if I differentiate this once to give me f dash of x, then it's just standard differentiation. 3 drops to the front, take 1 away from the power. The 2 will drop to the front to make a 4, and we get an x here. And then the minus 8x will just go to minus 8, and then the 5 will disappear. So this is our f dash of x, and we need to differentiate one more time to give us f double dash of x. Again, we're going to have 6x and then plus 4. So that is fine. That's part A done. Let me just write part A. Then part B says, for part I, we need to solve f double dash of x is equal to 0. Okay, so that's fine. Let me just write this here. Double I. So f double dash of x is 6x plus 4. So I'm just going to say 6x plus 4 is equal to 0. If I move the 4 over, this will give me a 6x is equal to negative 4. And that must mean that x is equal to negative 4 over 6, which simplifies to minus 2 over 3. So that's part I done. And then part double I says, hence find a range of values of x for which f of x is concave. Okay, so just remember with concavity, when you're trying to prove a function is concave, that just means that your second derivative, right, is less than or equal to 0. So all that means here is that we'll find our second derivative was 6x plus 4 is less than or equal to 0. Solving this inequality will give us 6x is less than or equal to negative 4. And then that must mean that x is less than or equal to negative 4 over 6. Or again, we can simplify this to negative 2 over 3. So therefore, your final answer for double I is x is less than or equal to negative 2/3. And you're done. That's question 1 finished. Okay, so question 2 says u1, u2, u3 is defined by u1 is equal to 35 and un plus 1 is equal to un plus 7 cosine n pi over 2 minus 5 lots of negative 1 to the power of n. And for part AI, it says show that u2 is equal to 40. Okay, so this is just a recurrence relation. This is not too bad. So let's see what we've got here. We've got u1, which we know is equal to 35. And they've given us the recurrence relation to go from one term to the other. So I'm going to say that un plus 1, let's go out again, un plus 1 is equal to un plus 7, sorry, plus 7 cosine of n pi over 2 minus 5 to the negative 1 to the power of n. Okay, now we need to show that u2 is equal to 40. That is just the second term, isn't it? If u1 is 35, u2 is the second term. So what I would like to do here is say, okay, fine. Remember the relationship between n plus 1 and n, this is just one after the other. If u2 is here, then this would have to equal u1. And then plus 7 cosine of n is 1 in this case, isn't it? So it's going to be 1 pi over 2 minus 5 minus 1 to the power of 1. So we need to just work this out and see what we get. Now, we know that u1 is 35, so I'm going to put 35 here. And then pi over 2. Let's draw the cosine graph very quickly. Cosine graph goes like this. So we've got pi over 2 here. This is pi, and this is 3 pi over 2. And it's probably going to be helpful for when we're finding the other terms. So in our case, pi over 2 is 0. That's fine. So it's going to be 7 lots of 0. And then minus 5 to the minus 1 to the 1. That's just negative 1. So this is 2 negatives here. And that's going to make a positive, isn't it? So therefore, I'm going to add these together. I'm going to add a 5 here. And then here, we've got 7 lots of 0. 0, 35 plus 5 is 40. So therefore, we were able to show that u2 is equal to 40. So that's fine. And then part double I says we need to find the value of u3 and u4. Okay, so that's not too bad. So double I, u3, we know will equal the term before it, u2, plus 7 cosine. And remember, in this case, n equals 2. So it's going to be 2 pi over 2 minus 5 lots of minus 1 to the power of 2. Now, u2 is 40. So I'm going to put 40 here. And then plus, and then 7 cosine of pi, right? The 2's will cancel, that's pi. And then minus 5. And then minus 1 squared is positive 1. So that's minus 5, that's positive 1. This is negative 5, that's fine. Now, if I look here, cosine of pi is negative 1, isn't it? Cosine of pi is negative 1. You can check on your calculator. So this will give us 40 minus 7. That is negative 1 minus 5. And this is just 40 take away 7 is 33. 33 take away 5 is 28. So this is 28. U3 is equal to 28. And then we need U4, don't we? So we're just going to do the same thing. So U4 will equal U3 plus 7 cosine of n equals 3. So 3 pi over 2 minus 5, lots of minus 1 to the 3. Now again, we know that U3 is 28 plus cosine of 3 pi over 2. Now 3 pi over 2 is back on the x-axis, is 0 again. So this is 0. And then minus 5. And then negative 1 to the power of 3 is negative 1. Two negatives will make a positive. So I'm going to be adding 5 here, aren't I? So therefore I've got 28 plus 0, which is 28 plus 5. This is 33. So therefore, we've got our values for U3 and U4 to 28 and 33. So that is part A done. Now let's go to part B. It says, given that the sequence is periodic with order 4, BI just tells us to write down the value of U5. Okay, now remember your definition of a periodic sequence. It's just where the terms in this sequence repeat in a cycle, right? So let's just put this here. I'm going to put BI here. And what I will do is I will just screenshot question B, so we don't need to keep going up and down. Okay, so I just paste it here and then bring it in here. Okay, so remember, periodic sequence, as I said before, is just a sequence where the terms repeat in a cycle. So for example, let's say I have E dot G. Let's say I have a random sequence 1, 2, 3, and then after 3 it goes back to 1, and then a 2, then a 3, and then so on and so forth. This is what we call a periodic sequence because the terms repeat in a cycle. Now, how many terms are in this cycle determines the order. So in this case, there are 3 distinct terms, 1, 2, and 3, and then it goes back to 1. So in this example here, the order is 3 in this example here. Now, in our question, they told us that the periodic sequence has an order of 4. And we know in part A that we were asked to find the first 4 terms, meaning that we have all of the terms in the cycle, don't we? So let's go ahead and put that in. So that means that we have U1, which was 35. U2, I believe, was 40, 28, and then 33. Yeah, so 40, 28, and then 33. And remember, they told us that this is a periodic sequence of order 4. So we've got the 4 distinct terms, meaning that the term after the 4th term, which is what they want, U5, has to be the first term, which is 35. So therefore, we could say that U5 is equal to 35, the first term in the sequence, or U1. Yep. So that's B part I done. Now part double I tells us to find the value of the sum from r equals 1 to 25 of this sequence. Remember, this is sigma notation. They're asking us to sum the first 25 terms. Now, when you're doing these recurrence relation questions, they don't actually want you to manually add up the first 25 terms. You need to look for a pattern. Now, they have told us that the sequence is periodic with order 4. So what I like to do when I'm doing a sigma notation and summing values is I like to write out, okay, so what does this mean? So we've got r equals 1, and then this is upward to 25 of UR. Now, this is just the first 25 terms. So in our case, it's going to be 35 plus 14 plus 28 plus 33. Sorry, not, sorry, 35, 40, 28, 33. Yeah, that's fine. That's actually fine. And then plus, and then we're going to go back to the first term and so on and so forth. This 28 and then 33, right? All the way up until the 25th term. Now, what we can see here is that all the first 4 terms, right, are the same, not the same, sorry, they're in a cycle, right? And then the next 4 terms are also in a cycle, right? Because it's periodic. So what we can say here is that, okay, well, fine. Well, we need the first 25 terms, and we know that the cycle repeats in 4s. Just ask yourself, how many times does 4 go into 25, the number that you want to sum to? 4 goes into 25 6 times with a remainder of 1, doesn't it? So what you'd be doing essentially is these 4 terms, right, which is 35 plus 40 plus 28 plus 33, right? You're going to be summing this up until 24 terms, right? So we've got 4 terms here. and then we have another 4 times, and then so on and so forth until we get to 24, right? And that happens 6 times. Yeah. So what we could say is that this here, I'm just going to 30 plus 40 plus 28 plus 33, right? This happens 6 times because we want it to 24. Yeah. So what we're going to do is we're actually going to just do 6 lots of 35 plus 40 plus 28 plus 33, right? This right here is going to give you the first 24 terms, right? Because there are 4 terms here and I'm doing it 6 times. 4 times 6 is 24. That's fine. And then remember, we need it to 25. So we just need one more term. Now remember, the order is 4. So once we've done the first 24 terms, we're going to go back to the first term of the sequence, which is 35, right? So that means I'm going to write 35 here. It's going to give us the 25th term. So what that means, to summarize then, is that your answer for the sum from r equals 1 to 25 of UR is just going to equal 6 lots of those first 4 terms. So 35 plus 40 plus 28 plus 33. And then we're going to add on the 25th term, which is 35. So this here will be your answer. So I'm just going to put this into my calculator. And as you can see, I've got it here already. 6 lots of 35 plus 40 plus 20 plus 33 plus 35 is equal to 851. So your final answer here is just 851. And that's question 2 finished. Okay, so question 3 says, given that log of x plus 3 plus log of x plus 10 is equal to 2 plus 2 log of x, and this is all with logs with base 2, we need to show that 3x squared minus 13x minus 30 is equal to 0 for 3 marks. Okay, this is not too bad. This is just applying our log rules, right? So I'm going to write this out again. So we're gonna have log of base 2 of x plus 3, and then plus log of base 2 of x plus 10. And then this is equal to 2 plus 2 log base 2 of x. Okay, so what I would do is use the log laws right now. On the left-hand side, I can see that I've got a sum of 2 logs with the same base. We know that we can multiply these together due to our log laws. Log a plus log b is log ab. So that would mean that this would become log base 2 of the product of those two arguments. So x plus 3 and x plus 10. So that would be simplified a little bit. And then on the right hand side, I've got a 2 here, that's fine. And then remember our log law, which states that the power in front can, sorry, not the power, the constant in front of the log can become a power with the term inside the argument. So that would mean that the 2 would become a 2 on the power of x. So it'll just be log base 2 of x squared. So I'm just using standard log laws here. Now, remember, we need to show that we get this here with no logs. So we just need to use logs to get it all together and then get rid of the logs at the end. So what I would do next is bring all of the logs together. So what I would do is this term here, I'm going to move to the left-hand side. So if I do this, this will give me log base 2 of that same thing, x plus 3, and then x plus 10. And then this is going to be taken away by log of base 2 of x squared. And this is all equal to 2. Now again, we've got a log here. I'm going to call this a, and then this here is just b, isn't it? Now we're just using the log law. Log a take log b is equal to log a over b. So if I use that here, then this will just become a log with base 2 of a, which is that there. So x plus 3, x plus 10. And then we're going to divide by b, which is x squared. So get this here, x squared. And then this is all equal to 2. So we are here. Remember, your show that is to show that we get this quadratic here. So we're looking for a quadratic at the end of the day. Now, when we're here, remember, we need to get a quadratic which has no logs in it. So what I would do here is get rid of this here. Now, you can use your equivalency form to just rewrite it in exponential form. But what I like to do when I'm dealing with these, if I want to cancel a log with any base, I'm just going to raise both of the sides of the equation to the base here. So this is a base of 2. So I'm going to write this like this. I'm going to raise them both with a base of 2 like this. What will happen is because these two bases are the same, they're going to cancel like this. Will just leave me with what's inside. And then obviously 2 squared on the right is 4. So we'll leave me with 2 squared, which is 4. Now what I'll do is I'll just copy this again, so I don't need to write it. So copy this here, and paste it here, and then bring it in. So that will leave us with this when I apply that. So now we're here, we just need to expand and simplify and blah, blah, blah. So this is not too bad. Let's expand the numerator first. So we're going to get, on the top, it's going to be x squared plus 10x plus 3x plus 30 all over x squared, and then this is equal to 4. Now this is not too bad, we're nearly done. Let me copy this onto the next page. Copy this into the next page and see what we get. So I'm just going to paste this here and then just expand and simplify. So let's do this. So this is just going to be x squared plus 13x plus 30 all over x squared is equal to 4. And then times on both sides by x squared will give us x squared plus 13x plus 30 is equal to 4x squared. And remember, we needed to show that we get this quadratic here. So let me copy this too, and not, and then see what we need to do. So we're here. We need to show this quadratic here. So that means that we just need to move everything from left to right, isn't it? Because I can see a 4x squared on the right. So if I move the x squared over, give me 3. So I'm going to move everything from left to right. That will give me 0 on this side. And then x squared on the right will be 4x squared take away x squared, which is 3x squared. And then the 13x will go to minus 13x, and then the plus 30 will go to negative 30. So we've got 0 is equal to 3x squared minus 13x minus 30, which is the exact same thing as 3x squared minus 13x minus 30 is equal to 0. So that is done. We've done part A. Now, let's have a look at part B. So it says, write down the roots of the equation 3x squared minus 13x minus 30 is equal to 0. So this is not too bad. You're just going to plug this into your quadratic solver in your calculator. So let me just get part B here again. Place this here, so then we have it. So we don't need to keep scrolling up and down. I'm just gonna make this a bit small so we can see it. Okay, it's a bit too small. Make it a bit bigger. Okay, so we're just gonna solve this. We're gonna put this into our calculator. So B and then I. Put that into our calculator. So let me go to number 1. Whoops, I need to go like this here, and then let me go to. Oh, I need to go to menu, and then I need to go to equations, functions, polynomial, and then degree 2. So we're going to plug in this quadratic here. So it's going to be 3 is equal to negative 13, and negative 30. It's negative 30. And this gives us one root as x is equal to 6. That's one of them. And then the other root would be x is equal to negative 5/3. So that is part B I done. Now double I says, hence state which of the roots in part BI is not a solution of this here, which is what we were dealing with at the first place, right? Given a reason for your answer. Okay, so whenever you're doing these with logs, remember, you've got to be careful. Remember, the argument of a log can only be positive, right? You cannot have a negative number in your argument. So what you need to do is just look at your values of x and just make sure that everything is okay. Now, if I start with this here, x equals 6 is not an issue here, is it? Because if I plug in x equals 6 into all of these arguments here, well, then this will just give me 6 plus 3 is a 9. Just give me a 9 here, which is positive. That's fine. This will give me a 16, which is also positive. That's fine. And then x is equal to 6 will be here. That's fine. So all of the arguments in our logs here is perfect. They're positive. So that's not an issue. So it's definitely not that one. So it's obviously negative 5/3, but always plug it in just to convince yourself in an exam. Okay. So if I plug in, I'm going to say x is equal to negative 5/3, right? If I plug this into all of the arguments here, so let me just go here, and then let's say, for example, I want to do the x plus 3. So negative 5/3 plus 3 is equal to 4/3, right? So that's actually fine, right? So that's 4/3 for the first argument. That's fine. The second one is going to be, I'm just going to add a 10 to that. So change that to a 10. 25/3, which is even bigger. So this is still not an issue. So it must be the last one. And yeah, when you plug in x equals negative 5/3 into that, this one right here will give you 2 lots of log base 2 of negative 5/3. This is an issue because remember, we know that the argument of a log cannot be negative. So this will have no real solution. Yeah? No real solution. And then obviously, if you try that in your calculator, if I was to plug that in, log of base 2 of negative 5/3, this would give us math error, wouldn't it? Yeah, it doesn't work. So your answer, to summarize, is that x is equal to negative 5/3. And your reason would be because when you plug in log of base 2 of 5/3, you get no real solution. It's not real. So therefore, your root which is invalid as x equals -5/3. And that is question 3 finished. Okay, so question 4 says coffee is poured into a cup. The temperature of the coffee, H degrees, T minutes after being poured into the cup is modeled by the equation H is equal to A e to the negative BT plus 30, where A and B are constants. Initially, the temperature of the coffee was 85 degrees. State the value of A for 1 mark. Okay, so that's fine, right? Remember, you've got this model here, which is H is equal to capital A e to the negative capital B T plus 30. Okay. Remember they said initially. Now remember this keyword initially. This just means at the start. It just means T equals 0 here, right? When T equals 0 initially, the temperature of the coffee is 85 degrees. And I remember they've told us that the temperature of the coffee is H. So all this is saying is that well, when T is equal to 0, H is equal to 85. So all you're going to do is just plug that in into your model here. So T equals 0 and H equals 85 into here. This will give us 85 is equal to A e to the negative B lots of 0 plus 30. Now, what do we have here? We've got 85. This is equal to A, and then remember, we've got e to the power of something with a 0. This power will be 0. E to the 0, right? We know is 1. Yeah? So therefore, we're going to have 85 is equal to A times 1, which is just A. So we get 85 is equal to A plus 30, and that must mean that 85 take 30 must equal A, and that must mean that A is equal to A, therefore A is equal to 55. So that is part A done, 55. That is the value of A. So let's go to part B. Part B says initially the coffee was cooling at a rate of 7.5 degrees per minute. Find a complete equation linking H and T given the value of B to 3 decimal places. Okay, so remember, again, we've got initially here, right? We know that initially just means that T equals 0. Now, another key word in this sentence here is rate, right? Rate. It's calling at a rate. Now, whenever you see these in modeling questions, that word rate is just another way of saying your dy dx or your gradient function, right? This is just your derivative, right? Whenever you see the word rate in a modeling question, it just means to differentiate. Now, our model was in terms of h and t. So what we would be looking for is the h by dt, wouldn't it? And it says that it's cooling at a rate of 77.5 degrees per minute, right? Now remember, it's cooling. That means that the temperature is decreasing. So what this actually means here is that this here, which we're going to call the h by dt, right? The h by dt will equal, right, negative 7.5. Remember, the model had a negative in the power of e, so it's cooling, right? It's decreasing. The gradient is negative. So it's just saying to finally summarize that when t is equal to 0, the h dt is equal to negative 7.5. So let's write this here. When t is equal to 0, the h by dt is equal to negative 7.5. So all we're going to do is just find out what the h by dt is, and then just equate it to minus 7.5 and plug it equals 0. So that's not too bad. So let's go ahead and do that. So h, we know, is equal to a, but a, remember, is 55. So it's going to be 55 e to the negative bt plus 30. If I differentiate that, it's going to give you the h by dt, and this will equal, remember how we differentiate exponentials, right? You differentiate the power. If I differentiate minus bt, that will just be minus b, wouldn't it? So that will drop to the front. So it's going to be negative 55b, right? That negative b is there with the 55, and it's going to be the same thing here, minus bt, and then the 30 will disappear. So this is our dh by dt, and we know that this is equal to negative 7.5, right? And this is when t is equal to 0, isn't it? So we're now going to plug in t equals 0 just to finish off. This will give us negative 55b e to the, if I plug in t equals 0, it'll be e to the 0 is equal to negative 7.5. So that way we would just have a negative 55, and then remember e to the 0 is 1. So it's just negative 55b is equal to negative 7.5. And that would mean that b is equal to negative 7.5 over negative 55, which is a positive number. I'll get my calculator out, see what that gives us. Putting this in, this will give us negative 7.5 over negative 55. and this gives us positive 3 over 22. So 3 over 22, or it's said to 3 decimal places, so it's going to be 0.136, wouldn't it? All right, so b is equal to 0.136. Now remember, we had to complete the model, right, for the equation linking h and t. So now we can say that, therefore, the final answer, I'll just do it here. Therefore, the final answer is going to be h is equal to, a was 55, so 55 e to the negative, and then b we now know is 0.136. 0.136, and then t, and then plus 30. So this right here is going to be your final answer. And that is question 4 finished. Okay, so question 5 says the curve C has equation y equals f of x. The curve passes through the point 3, negative 10 and has a turning point at P. Given that dy dx is equal to 2x cubed minus 9x squared plus 5x plus k, where k is a constant, show that k equals 12 for 2 marks. Okay, this is not too bad. So they've given us 2 bullet points or 2 pieces of information about this curve y equals f of x, which we don't know. First one is that it passes through the point 3, negative 10. So that just means that when x equals 3, you're going to get y equals negative 10. And the second bullet point is key here. It has a turning point at P. Now remember, when you see turning point in A-level maths, right? This is just a synonym for stationary point. A synonym for maximum point, minimum point. These all mean that your dy dx is equal to 0 here. So turning point, whenever you see this just means that dy dx is equal to 0. So in our case here, we know that the turning point is at P, where x is equal to 3, right? So all these 2 bullet points are saying is that, well, fine. All they're saying is that, well, when x is equal to negative 3, your dy dx is equal to 0. Right? So all you'd have to do is just plug in x equals 3 into your dy dx, set it equal to 0, and then you should hopefully get k is equal to 12 from that. So let's go ahead and do that. So I'm going to write out dy dx again. So we're going to say dy dx is equal to 2x cubed minus 9x squared plus 5x plus k. Now I'm going to plug in x equals 3 and set it equal to 0. So when I do that, I'm going to have 2 lots of 3 cubed minus 9 lots of 3 squared plus 5 lots of 3 plus k. And I'm going to make this equal to 0. Now what I'm going to do, just to make things quicker, I'm just going to plug in those values there. So it's going to be a 2 lots of 3 all cubed minus 9 lots of 3 all squared, and then plus 5 lots of 3, which is 15, but I'll just write like this anyway. This is negative 12. So I'm going to have negative 12 plus k is equal to 0. If I move the negative 12 over to the right, that just means that k is equal to 12. So we've done it. Okay, so that's part A done. 2 marks in the bag. Now part B says, hence, find the coordinates of the point where C crosses the y-axis. Okay, so we're trying to find where C crosses the y-axis. To find out anything about C, the curve, well, we need to figure out what the actual equation for it is, right? We need to figure out what y actually is. So for us to do that, remember, we've been given a gradient function, yeah? And we know that from part A, k is 12. So we've got a complete model for our derivative, right? So I'm going to say part B, I'm going to say dy dx is equal to 2x cubed minus 9x squared plus 5x sorry, plus k, which we know is 12, so plus 12. And they're asking us about C, and we're looking for the where the curve crosses the y-axis, right, which is the y-intercept. So for us to find C, right, the curve, well, remember, when you have a gradient function, you need to integrate, don't you? So to find y, we will need to integrate dy dx, would it be? Dy dx, and that just means we have to integrate 2x cubed minus 9x squared plus 5x plus 12. That's what we need to do, and this will give us our y. Now doing this will give us, I'm going to add 1 to the power, divide by new power, so 2x to the 4 over 4, and then minus 9, and then x to the 3 over 3, and then plus 5x squared over 2, and then plus 12x, and then plus your constant of integration. This is equal to y. So what I'm going to do is, let me just copy this, and I'm going to tidy this up on the next page, and then plug in the values to get C. So this is our y, this is our function y equals f of x, right? Now let's just tidy this up a bit. So when we do this, we're going to have y is equal to 2 over 4 is a half, so a half x to the 4. And minus 9 over 3 is 3, so 3x cubed plus 5 over 2x squared plus 12x plus our constant of integration. Now remember, to find out what uh, your c is, your constant of integration, you need a point that passes through your curve. And that was the first bullet point they told us. They told us that the point P is 3, negative 10, and it passes through. So we could use that to figure out what c is. So I'm going to just put this here. Let's say P is a 3 and a negative 10. So when I plug this in, this will give me negative 10 for y is equal to a half, and then a 3 to the 4 minus 3 lots of 3 cubed minus, sorry, not minus, plus 5 over 2, 3 squared plus 12 lots of 3 plus our constant of integration. So what I'm going to do now is I'm just going to plug in this part on the left-hand side and see what it gives us. So this will give us 1 half to the 3 to the 4, and then minus 3 lots of 3 cubed, which is just 3 to the 4, but anyways, I'll just do it like this, and then plus 5 over 2, 5 over 2, and then 3 squared, and then plus 12 lots of 3. And that will simplify a whole lot of this equation, which is 18. So we're going to have equals, we're going to have minus 10, and this whole thing is 18, so 18 plus c, and that just means that, well, c is going to be minus 10 minus 18, which is c, so therefore c is equal to negative 28. So now we know the constant of integration, right? We know what the y-intercept is of this curve. The question asked us for the coordinates of the point where C crosses the y-axis. Well, we know that the y-intercept is negative 28, so therefore the coordinates where the curve crosses the y-axis would just be 0, negative 28. And that is done. That is question 5 done. Okay, so question 6 says, relative to a fixed origin O, A is the point with position vector 12i, B is the point with position vector 16j, C is the point with position vector 50i plus 136j, D is the point with position vector 22i plus 24j. Part A says we need to show that AD is parallel to BC. Okay, now remember, even from GCSE, whenever you're trying to show two vectors are parallel, you just need to be able to express one vector as a multiple of the other. So all we need to do here is figure out what the vectors A to D are and B to C and see if we can write them as multiples of one another. So let's go ahead and do that. So I'll do this here. So I've got part A. Let me just change the ink. So A, write this out again. So part A, we have A to D is what we're trying to find. So the vector A to D, remember, it's just the same as taking away the components D and A. So D take away A. So what I'm gonna do is I'm going to write these in columns just so it's just easier to see. So the vector D is 22i, so 22 on the top here and 24 on the bottom. That's in column form, and then take away A, which is just 12i. So it's going to be 12 and then 0 on the bottom here. If I take these away, this will give me 22 take away 12 is 10, so I have 10 here. And then 24 take away 0 is 0. So it's 24. So I'm going to have 10 and 24. So therefore, we could say that our vector A to D, right, is equal to 10 and 24, right? This is in column form. So we've got A to D. Now let's figure out what B to C is. Now B to C, same thing, is going to be C take away B. So let's go ahead and do that. The vector C is 50i and 136j. So it's going to be 50 and 136. And then take away B, which is 16j. So it's just going to be 0 for the I component and then 16 on the bottom here. So this is it here. Now we're going to take these away. 50 take away 0 is 50. And then 136 take away 16 is 120. So this is our vector B to C. Now we've got our vectors. We just need to ask ourselves, are these multiples of one another? And yes, they are, because if I look at the vector B to C, this is 50 and 120, right? If I take out a 5, right, then this becomes 50 divided by 5 is 10. And then 120 divided by 5 is a 24, right? And 1024 is the exact same as the vector A to D. So this is actually just 5 lots of the vector A to D. So what we've shown here, A to D, what we've shown here is that we could say, well, B to C is equal to 5 lots of A to D, isn't it? Or in other words, we could just say that 1/5 of B to C is equal to A to D, right? So we were able to write the vectors as multiples of one another, and that would show that they're parallel. So just remember to get your final mark, just to say, you've got to just conclude, say, therefore, what did they say? A to D is parallel to B to C. So you're just going to say, therefore, AD is parallel to BC. And that would be part A. So we've done that. Now let's have a look at part B. It says points A, B, C, and D are used to model the vertices of a running track in the shape of a quadrilateral. Runners complete one lap by running along all four sides of the track. The lengths of the sides are measured in meters. Given that a particular runner takes exactly 5 minutes to complete 2 laps, calculate the average speed of this runner, given your answer in kilometers per hour. Okay, so the question is to work out the average speed. That is just the distance divided by the time, isn't it? So what we need to do is just work out what the distance is, divide that by how long it takes, and that will give us our answer. Obviously, we need to account for the units of measurement here as well. So what we're going to do is I'm going to screenshot that question, part B, just so I don't need to keep going up and down. I'll paste it here and then bring it inside so I can have a look at it. Okay. And also what I'll do actually is I'll get the information about the vectors too, because I'm going to need that, aren't I? So let me just get this here as well. Okay, so we've got everything that we need to answer this question. So let's have a look. All right, so we've got this here. Okay, so what do we have here? They've told us that we need to work out the average speed of this runner, and the points A, B, C, and D are modeled to be vertices of a running track, right? Which is a quadrilateral. So what I would do is when I'm doing these types of questions, I like to see the question. I'm going to visualize it. So I'm just going to draw a quadrilateral and put the points on, right? So I'm going to draw a quadrilateral. What do we know, by the way? Remember, from part A, we know that A to D is parallel to B to C, isn't it? So let's just say, for example, I've got, for example, let's just double check which one was bigger. B to C was larger, A to D was smaller, right? So let's go ahead and do that. I'm going to say A to D is on the top here. Let's say this is A to D, this, and then B to C I know is 5 times as long as this. So I'm going to just say this is something like that. And then this is going to be a B to C, right? And then now I'm going to just connect these. So let's just say that this racetrack is a trapezium, right? Two parallel sides, not a problem. So let us do this here. Let me just connect this here. Okay, now we've got somebody that's running along these tracks, right? We need to figure out how uh we need to figure out the distance, don't we? I remember they've just given us vectors in this question. We know to go from one vector to another, the distance is defined by the magnitude. So what we would need to do is just find the magnitude of all of these sides, A to D, D to C, B to C, and A to B, and then that will give us the distance of all of the sides of the racetrack. So this is not too bad. So let's go ahead and do that. So firstly, let's look at A to B. We need the magnitude of A to B. A to B. Well, this is just going to be the magnitude of the Pythagoras of the difference of the components, isn't it? So I'll do this here. So square root, and then A to B, right, is B minus A, which is right here. So what I'm going to do actually, let me write these in column form. So vector A is 12, 0, like this, and then B is 0, 16. Yeah, 0, 16. Oops, 16 here, like this. And then that would mean that the vector A to B itself is just going to be those take away each other. So it's going to be B minus A. So 0 take away 12 is negative 12, like that there. And then 16 take away 0 is just 16. So I've got the vector of A to B, the magnitude, right, which is right here, is just going to be the Pythagoras of those two components. So it's going to be negative 12 squared plus 16 squared. So I'm going to put this into my calculator and see what it gives me. This will give me square root of negative 12 squared plus 16 squared. This gives us 20. Yeah, so we know that this here is 20. Remember, it was in meters, they said as well. So this is 20 meters here. Now I need to do the others. So for example, let's do A to D because we actually have those vectors anyway. A to D is going to be the magnitude of those components. So what was A to D again? A to D was 1024. This is A to D here, so I'm going to put this here. So if a to the is 1024, right out here again, a to the is equal to 1024. The magnitude is just going to be 10 squared plus 24 squared, which is equal to, do this here, change that to a 24, change this to a 10, uh, 10 squared like that. This gives us 26. Yeah, so this a to d is 26. So this is 26 meters here. And then B to C, remember B to C was just 5 times A to D, isn't it? B to C is 5 times A to D. So what you could do is just times that by 5, right? Or if you want, you could actually just plug in the components. So I'll just do both just to convince. So B to C, we know is equal to 50 and 120. So if I do the magnitude of that, that will give us magnitude of B to C. This will give us the square root of 50 squared plus 120 squared, which is equal to, put this in here, square root 50 squared plus 120 squared. And this gives us 130, yeah? Which we knew anyway, because 26 times 5 is 130 anyway. So you didn't have to do this, but I wanted to just do it anyway, just in case anybody else did it this way. So this is 130 meters. So I'm going to label that here. This is 130 meters. And then we've got one more to do. We've got D to C to find out. And let's go ahead and do that. So we've got the 2 points here. D and C are right here. So I'll just do it. I'll just do it here. D to C will equal, it's going to be, see, D to C is going to be C take away D. C take away D. And C is 50 for I 136 here, and then take away D, which is 22, and then 24 here, like this. So 50 take away 22 is 50 take away 20 is 30. This is going to be 28. And then a 136 take away 24 is going to be 112. So we got this here. This is D to C. So therefore, the magnitude, I'll do it here actually. A magnitude of D to C equal the Pythagoras of those. So it's going to be 28 squared plus 112 squared. And this gives us, let me do it here, square root of 28 squared plus 112 squared. Which moves this so you guys can see it a bit, is going to give us 28 root 17. Yeah, so 28 root 17. So that means we've got all of the distances of each part of this racetrack, right? Now, remember, it says that given that a particular runner takes exactly 5 minutes to complete 2 laps, right? So 1 lap will just be the perimeter of this quadrilateral. 2 laps would be 2 lots of the perimeter. So what I'm going to do is say, fine, 2 laps is going to equal 2 times the perimeter, right? So let's go ahead and work out what the perimeter is. I'll call it P. The perimeter is going to be these numbers added together. So what I'm going to do is just put this into my calculator. Let me whoops, zoom it out a bit. So I'm going to add these numbers up. So I'm going to do 20 plus 26 plus 130 plus 28 root 17. And this will give me an exact form of a set, isn't it? So I'll do this here. So it's going to be 20 plus 26 plus 130 plus 28 root 17. And this gives us, oh, okay, let me get rid of this just so I can get the integer part. Will give us 176, right? So it's going to be 176 and then plus that 28 root 17. So that is 1 lap, right? 2 laps, which you know is 2 times the perimeter. We're just going to times that by 2. So I'm going to times this by 2. Times this by 2, times by 2, right? This will give us that number times by 2. So it's going to be 176 plus oops, 176 plus the 28 root 17. Whoops. 176 plus the 28 root 17. We get this here, and then we're going to times this by 2. If I times this by 2, I get this number here. So now we have the total distance of his 2 laps, this runner here. So I'm going to screenshot this number here. So we get this here. So let me just paste it here. Paste this here. So this is our answer right here for the 2 laps. So we now know the distance covered by this sprinter. So we're nearly done. 2 laps is here. Now, what do we need to know? We need to know the time. Okay, it says it gives us the runner takes exactly 5 minutes. So we know the time. So we're pretty much done. So the 2 laps is that there. The time is equal to 5 minutes. So to answer the question, so remember the speed we know is equal to the distance over the time. In our case, the distance was that number there, 582.893915. 893915, and the time was 5 minutes. So remember though, be very careful. The question asked for the answer to be in kilometers per hour. Now remember that they told us that the lengths of the cells are measured in meters, right? So these are in meters at the moment, right? And the time is in minutes. So if we were to put this into the calculator, this will give us meters per minute. We don't want that. We want it in kilometers per hour. So we need to convert both of these, don't we? So let's do this one. Let me just write the units of measurement here. So this is in meters so far. This is in minutes. Yeah. So this one, we know that, for example, there are 60 minutes in 1 hour. So to go from minutes to hours, we're just going to divide by 60. So what I'm going to do is uh I'm doing the bottom one, aren't I? 5 minutes. So I'm just going to do 5/60 to get this in hours. So we can say that 5 minutes is equal to 5/60 hours, right? Which is 1/12. This. So therefore, the denominator is going to be 1/12, and this is in hours. Now, the numerator, which is in meters, right? We need it in kilometers. We know that there are 1,000 meters in 1 kilometer. So to go from meters to kilometers, we need to divide by 1,000, don't we? So all we need to do is just divide that number by 1,000, and that will go on the top. So I'll go ahead and do this here. So it's going to be that number, answer divided by 1,000. This gives us this number here, which is, I'll screenshot this. So I don't need to write it out again. So put this here, and then I'll just paste this here. This, like this here. Okay, so this is the numerator, right? This is, I'm gonna write this. This is in kilometers, right? So that means our answer to the question is going to be, on the numerator, is going to be 0.582893915. So all I'm going to do is just plug this into the calculator and see what it gives me. So I'll just do this here. I'm just going to draw an arrow just to say that the answer then is going to be whatever that is equal to. I've already got this stored in my calculator. So all I'm going to do is I'm just going to do answer divided by 1/12. And this gives us 6.994, blah, blah, blah. What was the degree of accuracy? It was, they didn't state, so I would always give it to 3 significant figures. So the final answer for the average speed of this runner would be 6.99 kilometers per hour. And that is it. That is a question 6 finished. Okay, so question 7 says a curve has equation x cubed plus 2xy plus 3y squared is equal to 47. Part A says we need to find dy dx in terms of x and y. Okay, so when I look at this equation, this is an equation with x and y's together, right? This is not y in terms of x. So with that being said, the fact that it asks us to find dy dx and it's in terms of x and y means that we have to use implicit differentiation. So what you're going to do is you're going to differentiate the x terms on its own, normally with respect to x, but when you get to any y's, you have to use the chain rule, which is obviously what implicit differentiation is. So let's go ahead and do this. So I'm going to write out the equation again. So we've got x cubed plus 2xy plus 3y squared is equal to 47. Okay, now what we're going to do is we need to find dy dx. So we're going to differentiate with respect to x. If I differentiate this term with respect to x, well, this is just going to be 3x squared. That's not a problem. Now, when I look at this, I've got two functions. I've got a function 2x here, and I've got the function y, right? So what I need to do is I need to use the product rule and differentiate the y implicitly and just plug it into the formula. So what we're going to do here is we're going to say that, for example, I'll do so. I'm going to say this is u and this is v. Just a quick reminder, if y is equal to u v, then dy dx is equal to u v dash plus v u dash. So all we need to do now is just figure out what those are. So what I'm going to do is I'm going to do these here. So I'm going to say u is equal to 2x here, and I'm going to say v is equal to y. U dash is going to be 2, and then v dash. Now remember, when you're differentiating y with respect to x, you differentiate with respect to y. So differentiating y will give you 1, and then you're going to multiply by dy dx. So it's going to be 1 times dy dx. So therefore, we can say v dash is just equal to dy by dx. Now that we've got everything we need, we can just use the formula for the product rule. So it's going to be u and v dash. So it's going to be 2x and dy dx. So this term is going to be 2x dy by dx, and then plus vu dash, which is just going to be 2y. So that's going to be 2y here. So this term here, 2xy, differentiates to 2x dy dx plus 2y. And then now, let me just move this a little bit to the left because I think I'm going to run out of room. So what I'll do is I'll just rub these out and do it like this, just so we can see. So this term is this one, and this term is this, all of this here. Yeah. Okay. Now the next term, which is 3y squared. Now remember, we're differentiating with respect to x. Don't forget. So you differentiate with respect to y, which will be 6y, and then you're going to multiply by dy dx like this. So that's done. And then this is equal to, now remember, don't forget to differentiate your constant. This is just going to be 0. So this is here. This is our equation for our derivative with respect to x of this equation here. Now remember, they're asking us for dy dx. So all you have to do here is just bring the dy dx's together, move everything to the other side, and then just factorize and blah, blah, blah. Simple stuff. So what I'm going to do is I'm going to keep the dy dx terms on the left. So I'm going to say 2x dy dx, and then plus, and then that is 6y dy dx. And this is going to equal, if I move those two terms over, it's going to be negative 3x squared, and then minus the 2y. Okay, so now what I'm going to do is I'm going to factor out. So whenever you get here, this is just basically making something the subject, isn't it? We're going to take out this dy dx. This will give us dy dx on the outside. And then this, sorry, not equals. I'm going to factor out. This will give us 2x plus 6y in the bracket. And then this is equal to negative 3x squared minus 2y. And then now to get dy dx on its own, we're just going to divide by that factor. So minus 3x squared minus 2y. We're going to divide this by 2x plus 6y. So therefore, this is our answer for dy dx. And what you can do, these negatives I don't really like, you can take that out, can't you? You can pull out a minus 1, and the numerator will just be 3x squared plus 2y. And then this is all over 2x plus 6y. So you can write your dy dx like this, and I think this is neater. So this is our answer for part A, and this will give you 4 marks. Okay, so we've done part A, now part B. It says at the point P, negative 2, 5 lies on the curve. Find the equation of the normal to the curve at P, given your answer in the form of ax plus by plus c is equal to 0, where a, b, and c are integers to be found. Okay, so this is very simple. So we need to find the equation of the normal. So all we have to do now is plug in the values of x and y, which our point P is on, into our gradient function, isn't it? Which is right here. Now remember, we've differentiated implicitly, so our gradient function is in terms of x and y. So we're going to plug in both x and y into our dy dx, and that will give us the gradient of the tangent at the point P, and then we're just going to do the negative reciprocal to get the gradient of the normal. So I'm going to I'll do it here. Have I got room? Yeah, I'll do it here. I've got a bit of room. I'll do it on the bottom, then I'll do the rest on the other page. So plugging in P minus 2, 5 into this formula here. This will give us dy dx is equal to, and then it's going to be, I'm going to use this form because it's easier to put in. It's going to be a minus, and then it's going to be, I don't need the bracket, I'm going to write anyway. 3 lots of x is negative 2, so negative 2 squared, plus 2 lots of y, which is 5. And then this is all over 2 lots of x, which is negative 2, and then plus 6 lots of y, which is 5. So this will give us the gradient of the tangent when I plug it in. So I'll do this here. Just get rid of this from last question. This is going to be a fraction. I'll put a minus on the outside, put a bracket here. It's going to be 3 lots of a negative 2 squared. Negative 2 squared, so 3 lots of negative 2 squared, that's fine, plus 2 lots of 5. like that, and then divided by 2 lots of -2 plus 6 lots of 5. And this gives us -11, -11 over 13. Now remember, this is the gradient of the tangent, right? The normal gradient is just going to be the negative reciprocal of that, which is going to be positive 13 over 11. This is the normal gradient here. So now we've got everything we need to. So I'm going to just finish off on the last page. So I'll just get this question again. This here. So remember, whoops, need to do this again. Copy it one more time. Okay, paste here. Okay, this is the question. And everything we know is what we have. So we've got the normal gradient. So in this case, it's going to be m is equal to 13 over 11. And the point P is -2, 5. So all we're going to do is we're just going to use y minus y1 is equal to m, and then x take x1. So doing this is going to be y take away 5 is equal to m, which is 13 over 11. And then that's going to be x take -2, like this. And then this will give us y take 5 is equal to 13 over 11, and then x plus 2, isn't it? And we need it in this form where a, b, and c are integers. We've got a fraction here. So this is, we know what to do here. I'm going to times by 11 everywhere. This would give me 11y minus 55, right? If I times by 11. If I times by 11 on the right hand side, that 11 will cancel. So it'll just be 13 and then x plus 2. Then I'm just going to expand and simplify and tidy up. So it's going to be 11y minus 55 is equal to 13x plus 26. And then we need an ax plus by plus c is equal to 0. So I'm just going to move everything from the left to the right. So I have 0 is equal to 13x, right? If I move that 11y over, I'm going to have minus 11y. And then I've got the plus 26 here. And then that's going to be plus 55. So therefore, your answer is going to be 0 is equal to 13x minus 11y. 26 plus 55, 20 plus 50, 70, 76 is 81. So therefore, 0 is equal to that, which means that this is the same as 13x minus 11y plus 81 is equal to 0. And that is it. That is question 7 finished. Cool. Okay, so question 8 says, express 2 cos theta plus 8 sine theta in the form r cos theta minus alpha, where r and alpha are constants, r is greater than 0, and alpha is between 0 and pi over 2. Give the exact value of r and give the value of alpha in radians to 3 decimal places. Okay, this is for 3 marks. So with this one, this is a very straightforward part A. So we've got 2 cos theta plus 8 sine theta, right? And we need to express it in this form here. Now, this here, when you're doing these types of questions, it's just using the addition formulae. So what we're going to use, we're going to use the negative, the subtraction version of it. So remember that is equal to, if I have cosine of A minus B, then this will equal cosine of A, cosine of B. And then that's negative. We flip this to a plus, and then it's just sine A, sine B. Now, if I replace A and B with theta and alpha, then it will just become theta take alpha is equal to cos theta cosine alpha plus sine theta sine alpha. Okay, so we are here. Now remember, we need it in this format here where there's an r in front of it. What that means is that we're just multiplying by r here. So if I do this, remember this is an equation. If I do this on the right hand side, then what will happen, let me just move this a bit to the left here, then it will just be an r here, isn't it? It'll be an r here, and then I have to put this in a bracket. Now if I expand that bracket, then that will give me a r cos theta cos alpha, and then plus r sine theta sine alpha. Now again, we need to express this in this form here. Yeah, we need to express this in this form here. So what we could say is that the two cos theta plus the 8 sine theta, this has to equal the r cos theta cos alpha and the r sine theta sine alpha. Okay, so we've got this here. All right. Now, when you get to this part, all you're doing with this question is just equating coefficients. So what I'm going to do is I'm just going to reorder this. You don't have to. I'm sure you guys will be able to do it without it. But I'm just going to reorder these two. I'm going to swap these two terms over. So it's going to be r cosine alpha cos theta plus r sine alpha sine theta. And then I've still got this on the left-hand side, this here. Now, if these two expressions are the same, it must mean that the coefficients have to be the same, which is where equating coefficients comes from, right? So this here would have to equal this, and then this 8 here on this side, multiplying the sine, would have to equal this one here, yeah? And as you can see, you've got the cosine here, and then you've got the sine here and the sine here, right? So if I just look at the two in blue, that tells me that r cos alpha is equal to 2, and then if I look at the 2 in green, it tells me that r sine alpha is equal to 8. Now, when you get here, once you get this here, I think you can just say that r is equal to the Pythagoras of 2 squared plus 8 squared. But this isn't a mark scheme. But for us that maybe don't know how we get this, I'll just explain it. So I've got these two equations, equation 1 and equation 2. I'm going to square both of these equations. So if I square equation 1, it will give me r squared cos squared alpha is equal to 2 squared if I square equation 1. And then if I square equation 2, it will give me r squared sine squared alpha is equal to 8 squared. Yeah. And now if I add these two equations together, it will give me r squared cos squared alpha plus r squared sine squared alpha. This will give me 2 squared plus 8 squared. Now remember, you're looking for r. If I look at the left-hand side, I've got a common factor of r squared, which I can take out. Then I have cos squared alpha plus sine squared alpha. And then this is equal to 2 squared plus 8 squared. Now remember, cos squared plus sine squared is always equal to 1. So we just have r squared times 1, which is r squared. So we have r squared is equal to 2 squared plus 8 squared, which must mean that obviously r is equal to the square root of 2 squared plus 8 squared. So that's how we get this here. Now, I can't remember if you actually have to show this in the exam, but yeah, I'm sure you guys will let me know in the comments. But yeah, so that's that. So obviously now we can figure out what r is. So let me put this here. So it'll be the square root of 2 squared plus 8 squared. And then this is equal to 2 root 17. So r is equal to 2 root 17. Perfect. All right, now we need to figure out what alpha is. Now, again, we need these two equations. So what you need to do whenever you're trying to find out alpha is you need to express these in terms of tan, right? And remember, tan alpha, we know is equal to sine over cos, right? So what that means then is that we need to divide these equations, right? So what I'm going to do, because sine is on the bottom, it's number 2, I'm going to do equation 2 divided by equation 1 because I want the sine on the top and the cos on the bottom. This will give me r sine alpha divided by r cos alpha, and this will equal 8 divided by 2. And then we can see here the r's will cancel. Sine over cos is tan, so this will give me tan alpha is equal to 8 divided by 2, which is 4. And then from here, we can just do the tan inverse, can't we? So we can say that alpha then is equal to the tan inverse of 4. Put this into my calculator. Tan inverse of 4 is equal to 1.3258, blah, blah, blah. It did say to 3 decimal places, so it'll be 1.326. So alpha will be 1.326. So that's fine. We've got our r, we've got our alpha. This will give us 3 marks. So that's done. Now let's go to part B. It says the first 3 terms of an arithmetic sequence are cos x plus sin x, cos x plus 2 sin x, where x is never equal to n pi. Given that S9 represents the sum of the first 9 terms of this sequence as x varies, part B tells us to find the exact maximum value of S9. Okay, so what do we have here? We've got an arithmetic sequence, right? It's an unconventional one because obviously we don't normally see the terms in terms of trig expressions, but it's still an arithmetic sequence all the same, meaning that you're going to have a first term, you're going to have a common difference, and you're going to have your SN formulas and so on and so forth. So what I would do is let me just screenshot this question here, so that way I don't need to keep going up and down. And let me just paste this here, then bring this in like this here. Okay, so let's have a look now. Now, if I analyze this, remember we need S9. This is the sum to the first 9 terms. Remember the SN formula is equal to SN is equal to n over 2, and then 2a plus n minus 1d, right? Where you need your n terms. In this case, we're looking for the first 9 terms, so n equals 9. Now, if I analyze the sequence, right, the first term in this sequence is cos x, so therefore a is definitely equal to cos x. And then the common difference is how do you go from one term to another? If I analyze each term, I've gone from a cos x to then a cos x plus a sin x. So I've added sin x here. And then I'm at cos x plus sin x. And then the only difference is that there's one more sin x, meaning that I've had to add another sin x. So therefore, our common difference is definitely sin x. So now we've got everything that we need. We just need to find an expression for S9. So we're going to say that S9, let's say S9 is equal to 9 over 2. And then 2 lots of A. A is cos x, so 2 cos x. Plus, and then n minus 1. N is 9, right? So 9 minus 1 is 8, so it'll be 8. And then D is our sin x here. So this is our expression for S9, right? So this is good. Now the question asks us to find the exact maximum value of S9. Okay, so we need to figure out the maximum value that this could be as x varies. Now, remember when you're doing these types of questions, they always follow from anything you've done before. Now, that 2x, that 2 cos x plus 8 sin x is exactly what we were dealing with in part A. Remember part A told us to express 2 cos theta plus 8 sin theta in the form of r cos theta take alpha, right? The only difference in our case is that our theta has been replaced with an x, right? So what I'll do is I'll just say, just following from question 1, right? We know that 2 cos x, right, plus 8 sin x, right, was equal to r and then cosine of x minus alpha, right? So in this case, all I'm doing is I'm just replacing theta with alpha. Sorry, theta with x. Yeah, that's all that's happened here. And then remember, we already know what r and alpha are, right? We know that r was 2 root 17. And then we've got cos x. And then alpha was 1.326, wasn't it? Yeah? So I've got 1.326 here. And then this is equal to 2 cos x plus 8 sin x, right? And then what we can do now is we'll say if S9, sorry, if S9 was equal to 9 over 2 multiplied by all of this here, right? Well, we know that this here is the same as this. So I'm going to replace it. And that's the whole point of this topic. You want to express this on the left into something in terms of one singular trigonometric expression, because that way you'll be able to see what the max and minimums are. So I'll just replace it here. So I'm going to have 2 root 17 and then cosine of x minus 1.326. This. Okay, now this is our S9. Now remember, we need to figure out where the exact maximum value of S9 is. Now, when I look at this here, always analyze what's inside here. Now remember, you've got 2 root 17, right? And you're multiplying it by this expression here, yeah? So the only way that S9 will change is dependent on this trigonometric expression here. 9 over 2 and 2 root 17 are constants, right? Now, we need to figure out what the maximum of this is, yeah? And this is just a cosine graph, right? The max and min of a cosine graph, right, is just going to be between 1 and minus 1, yeah? So the maximum of this expression in blue is 1, right? Meaning that the max, all right, S9 max will just equal 9 over 2 multiplied by 2 root 17. And remember, this in blue varies. It varies between 1 and minus 1. The maximum of it is 1. So I'm just going to replace that with 1 here. So therefore, this is equal to the maximum of x9, and then just tidying this up. 2 root 17 is just times 1 is 2 root 17. The 2's will cancel here. That means that the maximum of S9 is 9 root 17. And that is our answer for the first part of B. So that's done. And then part I says we need to deduce the smallest positive value of x at which this maximum value of S9 occurs. Okay, so we need to figure out what value of x do we plug in for this to occur. Now remember what we just said. Let me just write BII here. The maximum of this expression occurs, right, when this in blue is equal to 1. So all you would need to do here is just solve, right? You just need to solve cosine x minus 1.326 is equal to 1. What value of x makes this occur? Yeah, so that's all you're going to solve. So to do this is not too bad. We're just going to take the cos inverse of both sides. So I'd have x minus 1.326 is equal to the cos inverse of 1. Now I'll put this into my calculator, see what it gives me. Cos inverse of 1 is equal to 0. So I'm going to get x minus 1.326 is equal to 0, meaning that x here must be equal to 1.326. And it says the smallest positive value. So this must be the first positive value, isn't it? So this is definitely the correct answer. And then was there any degree of accuracy given? No, there isn't. So if there isn't any degree of accuracy, just give it to three significant figures. So that must mean that x is equal to 1.33. And that is your question finished. This is question 8 finished. Okay, so question 9 says the curve C has parametric equations x is equal to t squared plus 6t minus 16 and y is equal to 6 ln t plus 3 where t is greater than -3. Part A says we need to show that the Cartesian equation for C is y is equal to a ln x plus b, where x is greater than -b and a and b are integers to be found. And this is for 3 marks. Okay, so this is a parametric equation question. Now we know what we need to do. You have a parametric equation, which you have your x's and y's in terms of a parameter t in this case. Sometimes it's theta, but it's t in this case. And to go from parametric to Cartesian, what you have to do is eliminate that parameter t. So when I look at this question, I can see that the show that is for y is equal to, right? Now, this is our y. And we've also got ln here, right? So for me, when I look at this, this tells me that I probably need to rearrange x to get t in terms of x. And once I've got an expression for t in terms of x, I will plug this into my equation for y. And then hopefully I'll get something of this form. So we're going to go ahead and try. So let's have a start. So I've got x is equal to t squared plus 6t minus 16. And now how do I make t the subject of something like this? Now remember, when you're dealing with a quadratic, what you should always do is complete the square whenever you're trying to make t the subject, right? It's the only way you can do it. So I'm going to complete the square, and this will give me, put this t, and then remember this coefficient needs to half, so t plus 3. We're going to square this bracket, and then we're going to take away the square of that number. So 3 squared is 9, we're going to take away 9, and then we're going to take away 16. And then tidying this up here, this will give us t plus 3 all squared, and then -9 takes 16 is -25. So therefore, I've got x, and this is in complete square form. Now it's going to be easy to figure out what t is. I'm going to add 25 to both sides. So I'm going to get x plus 25 is equal to t plus 3 all squared. And then I need to get t, so I'm going to square root both sides. So I'm going to get the square root of x plus 25 is equal to t plus 3. And then I'm going to take 3 from both sides. So I'm going to have the square root of x plus 25 take away 3 is equal to t. So now I've got t in terms of x. What I'm going to do now is plug in t into my equation for y, right? And see what happens. So I'm going to write it out again. We got y is equal to, what was it again? It was 6 ln t plus 3. 6 ln t plus 3. And I'm going to plug in t into there. So let me just highlight what I'm doing. So this t, I'm going to replace here. And we know that this is equal to it, isn't it? So I'm going to just write y is equal to 6 ln. And then instead of writing t, I'm going to write this here on the left. Root x plus 25 take away 3, right? This is our t. And then I still have to add that plus 3 on at the end. So it's going to be like this. It's going to be like that. And that plus 3 is on the end here. And then this here is our t. So we are here, right? Now, what we can do from here is, well, if I look at this, I've got a -3 plus a 3. Those will cancel out. So that will tell me that y is equal to 6 ln of the square root of x plus 25. And now this is good because what we've done is we've eliminated that parameter t and we've got y in terms of x. So this is in Cartesian form. Now the question is this in the form that they want it in? So let's just double check to show that. It was y is equal to a ln x plus b. Now there's no square roots here. So for me, when I look at this and I look at what I've got so far, it tells me that the square root needs to go. Now, what we can do is, remember, we're dealing with log, so always have your log laws in your mind. I've got 6 ln, and then we know that the square root of anything is the same as raising it to the power of 1/2. So I'm going to do x plus 25 all to the power of 1/2. And then we know that from our log laws, the half can drop to the front. So it becomes y is equal to 6, and then multiply by 1/2 ln of x plus 25. And then the 6.5 make a 3. So it's going to be y is equal to 3 ln of x plus 25. And let's compare that to the show that, yeah, there's no square roots. Now, yeah, this is perfectly fine. So we could say then that a must be the number in front. So a is equal to 3 and b must be 25. And this here is our answer to part A, and this is 3 marks. Perfect. Let's have a look at part B. It says the curve C cuts the y-axis at the point P. Show that the equation of the tangent to C at P can be written in the form ax plus by is equal to c ln 5, where a, b, and c are integers to be found. Okay, so I'm going to screenshot this just so we don't have to keep going up and down. So I'll do this here. Let me just paste this here. And then let's get everything that we need. So got this here. Let me just make this a bit small so it fits into the frame. I'll just make it tiny bit bigger. And what I'll do as well is I'm going to get the parametric equations too, because there are 2 ways to do this question. I'm going to just explain both, but I'll do it one of the ways. So, okay. So we need to find the equation of the tangent. Now, whenever you're trying to find the equation of the tangent, you need to differentiate, don't you? So what you can do, the first way you can do this question is you could figure out what dy dx is, right? By using your formula for parametric differentiation. We've got x and y in terms of t, so you can just say dy dx is equal to dy dt divided by dx dt. So in other words, you want to figure out what dy dt is, what dx dt is, and then plug in a value of t. Now it did say the curve C cuts the y-axis at the point P, right? And that would be where x is equal to 0. So all you'd have to do here is plug in x equals 0 into your formula, figure out the value of t, which corresponds to it. Remember, they did tell us that t is greater than -3, and then plug that in there. So you could do it that way. However, I'm going to do it the second way, because remember, in part A, we worked out the Cartesian form, isn't it? Remember, worked out the Cartesian form, which was this here. So we already have y in terms of x. So for me, I would just use that instead of doing this here. But you could do it either way, you'll get the same answer. So what I'm going to do is I'm going to say y is equal to 3 ln and then x plus 25, right? Let me just double check it's correct. Yeah, that's fine. And then what I will do now is I'm just going to directly differentiate this dy by dx, right? And now let's see what we have here. We've got an ln that we're differentiating. Now remember, when you're differentiating a logarithm, right? A natural log, so ln of f of x, right? If you differentiate this, this is always going to equal f dash of x divided by f of x. That's something you need to remember. Let me just write d dx here. So when I differentiate this here, well, the 3 is a constant. I'm going to be multiplying it. And then the function inside is x plus 25. That will go in the denominator. And then the derivative of this will go in the numerator. When you differentiate x plus 25, this will just be 1. So we get this here. So therefore, dy dx is just equal to 3 over x plus 25. So I'm going to say this is dy dx here. Now we have dy dx directly. We know that the curve C cuts the y-axis at the point P, which is what we need. And that is where x is equal to 0. So all I'm going to do is plug in x equals 0, and that will give me the gradient at the point that I'm looking for, the gradient at the point P. So if x is equal to 0, right, this will give me 3 over 0 plus 25, which is just 3/25. So this is the gradient of the tangent, isn't it? And that's exactly what we need. Now we need the point P, you know? So let me just put everything that we know. We know that the gradient that we're looking for is 3 over 25. We need the point P, and we know that the x coordinate, so I'll put xy for P, and then the x coordinate is 0, right? And then what is the y-intercept? The curve C cuts the y-axis at the point P. So I need to plug in x equals 0 into my formula for y, isn't it? I can just look at this now. Now again, I'm just going to write this here again. We know that y is equal to 3 ln of x plus 25. If I plug in x equals 0 into this, this will give me 3 ln of 0 plus 25. So therefore, this is just equal to 3 ln 25. And this is equal to y. So y is equal to 3 ln 25. So now I have my y coordinate. Now again, the question asks us for the equation of the tangent. So all we're going to do is just going to do y take y1 is equal to m, and then x take x1. This, and remember, this is a show that question. Always have your show that at hand, just so you can compare and contrast to make sure you're doing it correctly. So all I'm going to do is let me just screenshot this here. I'll probably finish on the second page. But yeah, this is what we need to get to. And let's plug in everything that we know. So we know that we have y minus y1. y1 is 3 ln 25, 3 ln 25. And then m, our gradient was 3 over 25 right there. 3 over 25. And then x minus x1. x1 is 0. So it's just this here. This is just us using the formula, and we need to show that we get this. So what I would do is, again, compare and contrast. The show that has ln5, we've got ln25, so that's a problem. So what I would do first is see if I can write this as an ln of 5. And you can do, because remember, let me just do it here. We've got 3 ln25. Now, 25 is the same as 5 squared, isn't it? So I could write this as 5 squared. And then remember, from our log rules, that 2, that power can drop to the front. So it just becomes 3 times 2 ln 5, which is just 6 ln 5. So we know that 3 ln 25 is the same as 6 ln 5. So I'm just going to say that y minus 6 ln 5 is equal to 3 over 25x. And then now we need to get ax and by, and they were constants to be found. So we definitely need to multiply by 25, because they did say a, b, and c are integers, right? This is not integer at the moment. So if I times everything by 25, right, then I'll have 25 y, right? And then 6 times 25, 25 times 10 is 250 divided by 2, 125. This is 150 minus 150 ln 5, and this is equal to 3x, right? This is where we're at so far. And then now we need ax plus by is equal to c ln 5. So what I'm going to do is I'm going to let me move the 25y over. So it's going to be minus 150 ln 5 is equal to 3x minus 25y. And that's just the same thing, isn't it? So we're going to say that 3x minus 25y is equal to negative 150 ln 5. And that would be your answer for question 9. Perfect. Okay, so just as a quick clarification for my final answer in question 9, I've got 3x take 25y is equal to minus 150 ln 5. Now, in the mark scheme, they've got a slightly different form, but rest assured, it's exactly the same. This is the mark scheme that I've got here, and they've got it in a slightly different form. But if I just copy what I have here and just compare it to that, well, all we can see is that if I times by negative 1 on mine on both sides, right? Then what will happen is that on the right hand side, this will become positive, so 150 ln 5. And then if I times both of these terms by a negative 1, this 3x will turn to negative 3x, so I'll put that there. And then this negative 25y will be positive 25y, so it'll be like this. And that is the exact same form that they got here. So this form that I have, that I wrote down, would give me the full marks, and so would this one too. So just to clarify, just in case anybody was a bit confused on that. And as well as that, they've also got this in the notes here. Final mark, 25y minus 3x is equal to 150 ln 5, or any integer multiple of this equation in the form ax plus by is equal to c ln 5. And that is what I got here. So just to clarify, that is definitely full marks. But yeah, thanks a lot for watching. So let's go to question 10 now. Okay, so question 10 says f of x is equal to 3kx minus 18 divided by x plus 4, x minus 2, where k is a positive constant. Part A says we need to express f of x in partial fractions in terms of k for 3 marks. Okay, this is not too bad. So remember, when you're dealing with partial fractions, right, you're going to write out the expression that they've given you. So 3kx minus 18 divided by, and then x plus 4, then x minus 2. And then what you want to do is you're going to set this equal to some constant a divided by the first factor, x plus 4. And then you're going to add another constant b, and you're going to divide this by the second factor, x take 2. Now, these are the same, so what we need to do is figure out what a and b are. And the way you do this is just by using algebra to manipulate it. Now, what you want to do first is you're going to multiply both sides by this factor here, x plus 4, x take 2. You're going to multiply both left and right by this whole factor on the bottom here. Now, when I do this for the left-hand side, it will just cancel, wouldn't it? So it'll be 3kx minus 18. And then on the right-hand side, when I multiply these two by this term here, the x plus 4s are going to cancel, aren't they? So it'll just be a and then x minus 2. And then plus, and then when I do it for the other one, it's the x minus 2s that will cancel, isn't it? So I'll be left with x plus 4, like this. Okay, now what you want to do when you're here is you're trying to figure out what a and b are. So you're going to set these factors here equal to 0. So when I set x minus 2 equal to 0, that means x must equal 2. So you're just going to say let x equal positive 2, and then plug in x equals 2 into this entire equation, left hand and right side. So if I plug in x equals 2 into this, that will be 2 here. 3 times 2 is 6. This will be a 6k. So I've got 6k take 18 is equal to a lots of 0 plus, and then plug it into 2, that'll be 6. It'll be 6b here. And then now we know that that's 0. So we're just going to have 6k take 18 is equal to 6b. And then obviously to get b now, we just need to divide both sides by 6, don't we? So we're going to say b is equal to 6k over 6 is k. And then 18 divided by 6 is 3. So it'll be minus 3 here. So we now know that b is equal to k minus 3. So that's fine. Now to get the a, what we're going to do is we're going to set this x plus 4 equal to 0 now. And that must mean x is equal to negative 4. So we're going to let x equal negative 4 here. And we're going to plug in x equals negative 4 into this equation. If we plug in x equals negative 4 here, we've got 3 and a negative 4, that's negative 12. So that's be negative 12k minus 18 is equal to, and then this will be a, and then this will be minus 4 minus 2 is minus 6, isn't it? And then this will be 0. So now b is eliminated. So now we can just say we've got minus 12k minus 18 is equal to negative 6a. So to get a, we're going to divide everything by negative 6, aren't we? Negative 12 divided by negative 6 will give me a positive 2. So it'll be positive 2k. And then negative 18 divided by negative 6 will give you positive 3. So therefore, we now have a, which is 2k plus 3. The question says we need to express it in terms of partial fractions. So what we're going to do just to finish off with part A is just replace a and b with these here. So therefore, your final answer would be a, which is a 2k plus 3, divided by x plus 4, plus b, which is k minus 3, over x minus 2. And that will give you your 3 marks. So that's done. That's part A. Part B says, hence find the exact value of k for which the integral of f of x between negative 3 and 1 is equal to 21. Okay, so this is the whole point of partial fractions. You've got some nasty type of function and you want to use partial fractions to decompose it so you can integrate it term by term. Yeah, so when they ask us to integrate f of x, we obviously know f of x is equal to this. But in part A, we were able to rewrite it in partial fractions. So we're going to use that expression instead of the original. So for part B, we want to integrate between 1 and minus 3 of f of x dx, which is equal to 21. So we're going to integrate between minus 3 and 1 of this expression here, instead of using the original expression, because that's the whole point of partial fractions. So we're going to do this here, and then x plus 4 plus k minus 3 over x minus 2 dx. Yeah, and this is equal to 21 apparently. And we need to find the exact value of the constant k. Okay. So how do we integrate something like this? Now, whenever you're doing year 13 integration, right, and you see a fraction, what I always do is I always check to see if the numerator and the denominator are derivatives of one another. What I mean by that is this, right? So for example, let's say I had, this is just a random example, right? Let's say I had the integral of a 2x on the top divided by x squared, right? When I differentiate x squared, I get the numerator 2x. So that would mean that this here would just be equal to the ln of the modulus of the function inside, like this. Yeah, so this is just the integral of f dash of x over f of x dx, and this is equal to ln of f of x, right, plus c. Yeah, and what you've got to do as well is also account for any constants as well. So this also works. For example, if it was k lots of this here, then the answer would just be k lots of this here, right? Be k ln of f of x. So when I look at this expression here, so let's look at the first one here. I'll do it here and then I'll write it all together on the next page. So I've got the integral of, if I do it turn by turn, I've got the integral of 2k plus 3 over x plus 4, right? Now, when I look at the denominator, I will have x plus 4. And then if I differentiate x plus 4, I will just get 1, isn't it? Right? The derivative of x plus 4 is just equal to 1. So what that means then is, for example, if they asked me to integrate 1 over x plus 4 dx, then according to this rule here, it would just be the ln of x plus 4, wouldn't it? Plus c. Now, if I compare this here with what I've got on the numerator here, well, how do I go from a 1 to a 2k plus 3? It's just going to be 2k plus 3 lots of the ln, isn't it? So what we could say, just to do this one here, the integral of 2k plus 3 over x plus 4 dx, this would just be equal to 2k plus 3 lots of the original integral, which is the ln of x plus 4. And that is how you go about integrating expressions such as these. Yeah, just make sure that you're just accounting for that factor. In this case, it's 2k plus 3. So when I do the other term, which was k minus 3 over x minus 2, k minus 3 over x minus 2 dx, right? When I differentiate x minus 2, I get 1, but I've got a k minus 3 on the numerator. So it's k minus 3 times the 1, isn't it? So the answer would just be k minus 3 and then the ln of x minus 2. So we've got both of these integrals here, right? So what we can do is bring these together. So what I'm going to do is, let me copy these. Let me copy this. This is exactly what I need. Paste this here. Hold on. Oops. Let me paste this here. And then I'll bring this here. So working this out, we know what each of these integrate to. So I'm going to say that now, because we've integrated them, we're just going to use definite integration to plug in the values. So the first one we know is this one here. So it's going to be 2k plus 3 and then the ln of x plus 4. And then plus the second one, which is this one here, k minus 3 and then the ln of x minus 2. And this is in between -3 and 1, and they've told us that this is equal to 21. So we need to just plug in our values, take them away, and figure out what k is. Okay, so let's go ahead and do that. Now, plugging in the upper limit is going to be, we're going to replace the x's with 1. So it's going to be 2k plus 3, and then the ln of 1 plus 4 is 5, so it'll be ln of 5, and then plus k minus 3, and then the ln of 1 take away 2 is -1, right? So that's what we've got here. And then what I'll do, because I think I've got room to write it all on one line actually. So let me move this a bit here. Okay. And then the lower limit, we're going to minus, and we're going to put a bracket here, and then plug in -3. So doing this is going to be 2k plus 3. And then the ln of -3 plus 4 is a positive 1. Yeah? Like this, and then plus k minus 3. And then -3 minus 2 is ln of -5, like this here. And then this is all equal to 21, isn't it? Now we've got absolute values, which is very good, because the absolute value of -1 will just be positive 1, isn't it? So this is just going to be the ln of 1. So do I need to write it out? Yeah, so what I'll do is I could just say, I'll just do a side check here. The ln of -1 is this equal to the ln of 1, isn't it? Which is 0. We know that the log of 1 is 0. So this term here is going to be k minus 3 times 0. This will just cancel out. I'm just going to write cancels here. Cancels. This will be 0. And it's going to be the exact same for this term, isn't it? This term is going to cancel as well. So we don't need to write it out again, because these two terms cancel. And then this ln of -5, like that is just the same as the ln of 5. So I'm just going to write this as ln 5 in the next line. So what's going to happen is that we're going to have 2k plus 3, and then the ln, I can just take off the natural log. I could take off the absolute values now. ln of 5, and then that cancels, so I won't have that anymore. And then minus, and then this cancels, I won't have that anymore. And then I have k plus 3, sorry, not k plus 3, k minus 3, and then the ln of 5, right? And then this is equal to 21. So I just need to tidy this up and see what I get. So what I'll do is let me expand this. Let me expand these and then put the minus after. So this will be minus, and then this will be k ln 5, and this will be minus 3 ln 5, wouldn't it? Like this. Just double check I've done that correctly. Yeah, that's fine. That's fine. It's equal to 21. And then we've got, expanding this one now is going to be 2k ln 5 plus 3 ln 5, like this. And then putting in the minus now, so it'll be I'll do it here, minus k ln 5 plus 3 ln 5 is equal to 21. And then we've got 2k ln 5 plus 3 ln 5. Now remember, we're looking for k, so let's get all of the k's together. I've got 2k ln 5 minus k ln 5. That will give me 1k ln 5, so k ln 5. And then I've got 3 ln 5 plus another 3 ln 5. This is just 6 ln 5, isn't it? Which is equal to 21. And then now we just need to move the 6 ln 5 over. So k ln 5 is equal to 21, take 6 ln 5. And then now to get k, we just need to divide everything by ln5, don't we? So k will equal 21 minus 6 ln 5 all over ln 5, right? And then if you want, this is our answer here, but if you want, we could just write it as 21 over ln 5, right? Separating the fractions, and then 6 ln 5 of ln 5 is just 6, so it's just minus 6. So you could just say your final answer is k is equal to 21 over ln 5 minus 6. And you're done. And this was question 10. Question 10 finished. Okay, so question 11 says a tank in the shape of a cuboid is being filled with water. The base of the tank measures 20 meters by 10 meters and the height of the tank is 5 meters as shown in figure 1. At time t minutes after the water started flowing into the tank, the height of the water was h meters and the volume of water in the tank was v meters cubed. In the model of this situation, the sides of the tank have negligible thickness. The rate of change of v is inversely proportional to the square root of h. Part A says we need to show that dh by dt is equal to lambda over root h. Okay, so this one isn't too bad. So whenever you're doing these types of questions where they ask you to show a derivative, right, all you're doing is the chain rule essentially. So let's just remind ourselves of the chain rule. So remember, if I have dy by dx, right, we know that this is equal to dy over some variable, which we're going to call u, multiplied by that same variable du over dx. Why? Because you treat these as fractions, and then these du's will cancel, and that will leave you with dy over dx here, which is what we've got here. So this is exactly what you're going to be doing with this question. You're just going to be looking for a chain of derivatives, right? So what I will do is I'm going to put, let me screenshot this here. So we need to show what dh by dt is. So what I would do is before I start trying to look at different expressions for different quantities, I would figure out what the chain is first for what I need, right? So let me just make this a bit smaller. Okay, so I need dh by dt. So it's going to be dh by dt is equal to dh would go here. And then I'm going to divide by something multiplied by that same something divided by dt, because the question marks will cancel. So then the question that you have to put to yourself is that what is that connecting variable that will connect the height and the time together, right? And what you could always do is just have a look at the question and see what variables you have used or have not used. Well, we know we have dh by dt, and we can see that we've got the time t, so that's fine, and we've got the height of the water here, h. The other variable that we haven't used is the volume, right? Which they told us is v, meters cubed, right? So that would be a good guess. Yeah. So what I'm going to say is that instead of writing the question marks, I'm going to replace them with dv's, right? And that seems like a good guess, right? So we need to figure out what dh by dv is, multiply that by dv by dt. Okay, so now we're here. Now let's see what we have. There was a bit of information, wasn't there? So there was a couple of bullet points. So it says, in the model of this situation, the size of the text have negligible thickness and the rate of change of v is inversely proportional to the square root of h. Okay, so let me put this down and see if that helps us. Okay, so I can't really get much from the first bullet point. The second bullet point, however, tells us about the rate of change of v, right? So if I break down this sentence, the rate of change of v, right? Well, what changes as the volume goes on? What changes is time, isn't it, right? So this is definitely going to be dv by dt, right? That is the rate of change of v. The volume changes as time goes on, right? And then this says that this is inversely proportional to the square root of h. Okay, so we know that that would mean that this is equal to, inversely proportional means I'm going to have k over, and then the square root of h, so I'm going to have root h here. So that tells me that dv dt is equal to k over root h. And then what that means is that I can update this, I'll call this equation 1. If I update this, it will become dh by dt is equal to dh by dv multiplied by dv by dt, which we figured out to be k over root h. So I'm going to put this here. And that just tells us now we need to figure out what dh by dv is. So in other words, we need a formula that connects the variables v and h, right? So that's the volume and the height. And that's pretty straightforward, because if I look at my diagram in figure 1, right? Remember, we're modeling the water being filled, right? And that will be the volume, isn't it? And we can see here that the formula for the volume is just going to be the length times the width times the height. So it will just be 20 times by 10 times by h, and that is just 200h. So we have now got a formula that connects v and h, which is good, because that means we can figure out the derivative, right? So what I'll do is I'll just write this here. We know that v is equal to 200h. And then that means that dv by dh, if I differentiate with respect to h, this is going to give me 200. And then remember, we want dh by dv, so we just do the reciprocal. So dh by dv is just going to be 1 over 200. Now we have an expression for dh by dv, we can plug it back into here. So we're going to get dh by dt is equal to 1 over 200 multiplied by k over root h. Then let's look at what they wanted us to show. We need to show that this is equal to lambda over root h. So this is good because we've got the root h here. Excuse me. But if you think about it, remember, k is a constant of proportionality, so it's a constant. And obviously, so is 1 over 200, right? So what you can do is just say to yourself, okay, well, fine. Well, that 1 over 200 I can put on the numerator. So it will just be 1 over 200, right? K, right? Over root h. And then dh by dt. And then again, 1 over 200 is a constant, so it's k. So a constant times a constant is another constant. So you could just say from here that 1 over 200k is your lambda. And that is perfectly valid. So you can just say, therefore, we get dh by dt is equal to lambda over the square root of h. So that's fine. We've got this here. Brilliant stuff. Okay. So that is part A done. Now let's look at part B. It says given that initially the height of the water in the tank is 1.44 meters, exactly 8 minutes after the water started flowing into the tank, the height of the water was 3.24 meters. Part B says use the model to find an equation linking h with t. Give your answer in the form of h to the 3 over 2 is equal to at plus b, where a and b are constants to be found. Okay, so this is not too bad. So this is just differential equations, isn't it? So we need to separate variables and then we integrate both sides and then we would get a general solution. And then they've given us these two bullet points, which will allow us to get a particular solution. So it's just straightforward. So let me screenshot this here. I'll do it. How much room do I have? I'll do it here. Okay. So this is what we have here. And let us get our model in part A, which was this here, right? So let me just copy this. So I'll just copy this here and then got this here. And then we need to get this from here. We need to get this with the initial conditions. So let us make a start. So what I'll do just before we start, actually, I don't like this lambda. It's not very nice. I'll draw it nicely like this. Okay. So remember, yeah, from here, we need to separate the variables. So let's go ahead and do that. We need to bring the h's with the dh's and the dt's with any constants. So I'm going to multiply by root h here. So I have root h dh, and this is equal to lambda dt. And then we're just going to put integral signs on both of these. And then now we can go ahead and integrate. Obviously, we need to change this though. The square root of h is the same as h to the power of 1/2. So I'm going to write 1 over 2 here. Okay, so now we need to integrate both sides. So when I integrate the left-hand side, I'll add 1 to that power. That will give me 3 over 2. I would divide by that power. Dividing by 3 over 2 would give me the same as multiplying by 2/3. So I'm going to write 2/3 here. And then when I do this one, it'll be lambda t plus c. Remember, lambda is a constant. If I integrate with respect to t, it will just be lambda t. So this is what we have here. And then now what we're going to do is we're going to use our initial conditions. So the first one says that initially the height of water in the tank was 1.44 meters. Again, we see initially all the time. This is just saying that when t is equal to 0, h is equal to 1.44. So we're going to plug that in. So I'm going to do this here. So that first initial condition states that when t is equal to 0, h is equal to 1.44. So I'll plug this in and this will give us I'll do it here. Will be 2/3 to the 1 times 1.44 to the 3 over 2, which is equal to lambda lots of 0 plus c. So that means that our constant of integration is just whatever this is equal to. So I'll put this in my calculator, and then this will give me let me just do it here so there's room. So just give me a 2 over 3 multiplied by 1.44 to the power of 3 over 2. And this is 144 over 125. So we now know what our C is. Yep, so that is good. So we can just say that the equation now becomes 2/3 h to the 3 over 2, which is equal to lambda t plus that constant of integration. Okay, now we're going to use the second bullet point to figure out lambda. Yeah. Now, the second bullet point told us that exactly 8 minutes after the water started flowing into the tank, the height of the water is 3.24. So again, this is just saying that when t is equal to 8, h is equal to 3.24. So we're just going to plug that in now. So I'm going to do this here. So it's going to be when t is equal to 8, h is equal to 3.24. So we plug this in and see what we get. So this will give us 2/3 and then 3.24 to the power of 3 over 2. And this is equal to t is 8. So it will be 8 lambda, isn't it? 8 lambda. And then plus 144 over 125. So now I'll put this into my calculator, tidy up and see what I get. So it will give me, I'm going to change this to 3.24 to see what this is. 3.24. And this is 486 over 125. So this will be 486 over 125. And this is equal to 8 lambda plus 144 over 125. Now, if I move that 144 over 125 to the left-hand side, that will just be 486 take away 144, which is going to be 342 over 125. And then this is equal to 8 lambda. And then that means that lambda is just going to be that divided by 8. So I'll just do this into my calculator. So let me just double check though. Answer minus 144 over 125. Yeah, that's fine. And then I'm going to divide this by 8. So answer divided by 8. This gives us lambda to be 171 over 500. So now we've got our lambda. So we could say that the complete model, I'll just do it here, is going to be 2/3 h to the 3 over 2, which is equal to lambda, which is 171 over 500. So I'll do this here. 171 over 500 and t plus that 144 over 125, and that will give you the 5 marks. And oh no, it won't actually. It won't, because it did say you need it in this form actually. So we need to be very, very careful. So what we need to do, we are here. We need to get rid of that 2/3. So we need to divide everything by 2/3, which is the same as multiplying everything by 3 over 2. So we're just going to multiply these constants by 3 over 2 and then see what that gets us. So I'll just finish off here on the last page. So let me just copy this and then put this here. And then I'll paste this here. And then let's just get the show that too. So let's see. Yeah, so I'll just copy this as well. Just get the form that we need. So yeah, again, this is where we're at. And we need to get h here. H to the 3 over 2. So I need to get rid of that 2/3, which is, again, we're going to times by 3 over 2 each term. So I'll do h to the 3 over 2. So I'll times by 3 over 2. That will cancel the 2/3. And then I'm going to times this 171 over 500 by 3 over 2. So I'll do this here. It's going to be answer times by 3 over 2. This gives me 513 over 1,000. So this would be 513 over 1,000 t. And then I'll do 3 over 2. I'll do 144 over 125. And I'm going to times this by 3 over 2 as well. And then this will give me 216 over 125. So 216 over 125. So therefore, let me just double check that there. Yeah, that's fine. So therefore, you can say that your A is just equal to 513 over 1,000. And your B is equal to 216 over 125. And then that will give you your 5 marks. So that's not too bad. That's not too bad. So we've done that. Now let's look at part C. Now, what does part C say? Oops, I need to go up here. Okay, there we are. So it says, hence find the time taken from when water started flowing into the tank for the tank to be completely full. Okay, well, when you're doing these ones, only 2 marks, so it doesn't require a lot. But have a look at your model again. We have a tank in the shape of a cube and it's being filled with water. We can see that quite clearly that the height of the tank is 5 meters. So if they want us to find the time taken for the tank to be completely full, that is just implying that the height has to be 5. So in other words, for part C, you're just going to find out what t is when h is equal to 5. Yeah. So I'll go ahead and do this. So yeah. So for part C, we need to find t when h is equal to 5. Because that is when the tank will be completely full. So all we're going to do is just plug in 5 into our formula. So it'll be 5 to the 3 over 2 is equal to 513 over 1,000 t plus 216 over 125. And then all we're going to do now is just take away the 216 over 125. So it'll be 5 to the 3 over 2 minus 216 over 125. And then to get t on its own, I'd have to divide everything by this constant here, 513 over 1,000. So it's going to be 513 over 1,000. So this will equal t. All I'm going to do now is just plug this into my calculator. So doing this here, it will be 5 to the 3 over 2, 5 to the 3 over 2, uh, minus 216 over 125 divided by 513 over 1000. And this gives us 18.42, blah, blah, blah. Was there any degree of accuracy? Uh, no, there wasn't. So I would give it to three significant figures. So that means that the answer for T, the time taken for the tank to be completely full, would be 18.4 minutes. So 18.4 minutes. And that would be our answer. And that is question 11 finished. Okay, question 12 says the number of subscribers of two different music streaming companies is being monitored. The number of subscribers, NA, in thousands to company A is modeled by the equation NA is equal to the modulus of T minus 3 plus 4, where T is greater than or equal to 0, where T is the time in years since monitoring began. The number of subscribers, NB, in thousands to company B is modeled by the equation NB is equal to 8 minus the modulus of 2T takes 6, where T is greater than or equal to 0, and again it's T is the time in years since monitoring began. Figure 2 shows a sketch of the graph of NA and the graph of NB over a 5-year period. Use the equations of the models to answer part A, B, C, and D. Part A says we need to find the initial difference between the number of subscribers to company A and the number of subscribers to company B. Okay, so with part A, this isn't too bad. So you're dealing with a model here and they've given you a graph, right? So it will be great to visualize it, right? You want to see what's going on. If you're looking for the initial difference between the number of subscribers, well, that's just going to be the values of n when t is equal to 0, which is just going to be our y-intercept. So, or I should say our n-intercepts in this case. So if I just get this figure 2 here, and I just bring this here for part A. So, and let me get those equations, by the way, because I'm going to need those, aren't I? So let me just get this here for this one. And then let me get the other one here for this one. So we've got this here. And again, we need the initial difference between the number of subscribers between both companies. So all that means is we're just going to look for the intercepts for the on the vertical axis. So we're just going to look here, isn't it? So the answer is just going to be the difference between these values here, wherever they are. And this is where t is equal to 0 for both of them. So all we're going to do is just plug in t equals 0 into both models and see what we get. So NA, when t is equal to 0, that would be NA is equal to 0 minus 3 plus 4. And then this is the modulus of negative 3, which is just going to be 3. So 3 plus 4 is equal to 7. So therefore, NA, which is this one here, this here is going to be 7. Let me rub this out, actually. Rub this out. This is going to be 7 here for this one. And then we're just going to do the exact same thing for NB. So it's going to be T is equal to 0 here. Whoops. Let's do this again. So it's going to be NB, and then we're going to say T is equal to 0 for that one. That'll give us NB is equal to 8 minus 2 lots of 0 minus 6, like that. And then that is just going to be 8 minus the modulus of negative 6, like this. And this is going to be 8 minus 6, right? The modulus of minus 6 is 6. 8 minus 6 is 2. So therefore, this is going to be 2 here. So the difference between 2 and 7 is 5. So this is going to be 5 here. So the answer is 5, but be very careful. Remember, the question says that the number of subscribers are in thousands. So it's going to be 5,000. So for part A, answer is going to be, I'll just write this here, 7 take away 2 is equal to 5. So therefore it's 5,000, as the number of subscribers was in thousands. So that's part A done. And then part B says when T is equal to capital T, company A reduced its subscription prices and the number of subscribers increased. Suggest a value for T given a reason for your answer. So again, let's just screenshot this part B. See what we get. So again, the graph is what's key here. You want to be looking at the graph just to see what's going on. So let me just reduce this here. And then let us get the graph again. I'll copy this and put it here again. Okay, so let's read what that piece of information said again. So it said that when T is equal to capital T, company A reduced its subscription prices and the number of subscribers increased. Suggest the value for T. Okay, so company A is this one going down then up. And apparently the number of subscribers increased after they reduced the prices. Well, we can see that the graph starts to increase here, isn't it? So I would say that the value of capital T would be this value here. So we just need to figure out what that is, right? So yeah, this is not too bad because the model of of NA. So it's a bit confusing. This is this is NA, isn't it? Yeah, that's fine. So yeah, the model of NA, which was equal to what was it? It was T minus 3, modulus T minus 3 plus 4. Let me just double check. Yeah, that's fine. Now remember, what is that value there? So just remember your graph transformations. Let's say this is the t-axis here. The modulus of t would be like this. The minimum point is at 0, 0. And then if I was to do, for example, the modulus of t minus 3, then this graph would shift 3 units to the right, wouldn't it? So it would be like this. Just be like this here, and then this would be at 3. And then obviously the plus 4 will shift it up, wouldn't it? So the plus 4 will shift it up here. So we can see quite clearly this graph here is going to be the modulus of t minus 3 plus 4. So we can see quite clearly that t is equal to capital T is equal to 3. This is the answer for part B. So suggest a value for t given the reason for your answer. Well, the reason is we can see from the graph quite clearly is that this would be the minimum value of the number of subscribers. After t equals 3, the number of subscribers starts to increase, isn't it? So you could just say for your reason at capital T is equal to 3, the number of subscribers, subscribers starts to increase. So that would be part B done. Okay, so that's done. And then let's look at part C. It says find the range of values of t for which NA is greater than NB, given your answer in set notation for 5 marks. Okay, so let's screenshot that and then let's get the diagram again. So again, we keep looking at the diagram. That's helping us answer these questions. So let me just put this in here. Put this in here. Okay, that's fine. We get that diagram one more time. Okay, and we're looking for, let's move this here. We're looking for when the number of subscribers in company A is greater than the number of subscribers in company B. Okay, so the critical values would be where they are equal to each other because either side of that, one's going to be greater or less than. So we can see that they intersect each other right here. So we're going to put here and here. So these values are going to be our critical values, right? Now, when I look at this here, so we don't know what these values are. So what I'm going to do for now is I'm just going to call these T1 here, and I'm going to call this T2. So these are our values of T. Now, we need the number of subscribers of A to be greater than the number of subscribers for B. So the number of subscribers for A is this one here, isn't it? The V, and it's greater before that T1, isn't it? It's before that T1 here. So this is when it's greater, right? And then after that value, in between T1 and T2, the number of subscribers for B, right, is greater, like this. And then it will start to drop down again, and then the number of subscribers for A will be greater. So the answer is going to be T is less than T1, right? And T is greater than T2. So our job is just to figure out what those values are, T1 and T2. So yeah, so we need to solve this. So let me get those equations again. So where were they? They were right there. Okay. So let me just copy these. Copy. Okay, no, it won't let me. Let me just write out again. So NA, we know actually was just equal to NA was equal to was it the modulus of t minus 3 plus 4, and NB I believe was 8 minus the modulus of 2t take 6. So let me just double check that just so I haven't got that written incorrectly. Yeah, that's fine. So we need the points of intersection. Those are the two values, T1 and T2. So we're going to make these equal to each other. So it's going to be T minus 3 plus 4 is equal to 8 minus modulus of 2t take 6. Okay, so when I look at this here, now the first point of intersection, I can see that the gradient of my NA line is negative, isn't it? It's going downwards. It's definitely going downwards. And the graph of NB, which is the green one, right, is going upwards, isn't it? So to solve this point of intersection, I'll need the gradient for the yellow line to be negative and the gradient for the green line to be positive. So the yellow line is NA. I would need this to be negative. So remember with the modulus, right, when you're dealing with modulus, if I have a modulus here, this just literally means plus this value or minus that same value, right? That's what the modulus does. So again, I need the negative of the yellow one, right, which is NA. So I need this gradient to be negative, meaning that T has to be negative. So it would make sense for me to make this the minus, isn't it? So for the first equation I need to solve, I'm going to make this one negative. So it's going to be negative T minus 3 plus 4. Remember, that would make the gradient negative, which is what we want. Now we're going to equal this to, we can see that the graph NB is going upwards, so I need the gradient to be positive. Now when I look here, I've got a minus here, right? So if I apply a minus to this, those two minuses will cancel out and it'll be positive. So I'm going to make this one positive. Sorry, I'm going to make it negative. So it becomes 8 minus, and then it's going to be minus 2t minus 6, right? And that's what we want because we want the gradient of this t to be positive here. So the two negatives will make it positive. So I'm solving this for my first equation. So let's go ahead and tidy this up. I'm going to have minus t and then plus 3 plus 4 is equal to 8. And it's going to be minus, and it's going to be minus 2t plus 6. Then tidy this up a bit more. So we get minus t plus 7 is equal to 8. And then plus 2t plus 6. Sorry, not plus 6, minus 6, isn't it? It's going to be a minus 6, like this. So tidying this up a tiny bit more, it's going to be minus t plus 7 is equal to 2t plus 2. So now to get t, let's move the minus t over. So it'll be 3t on this side. Take that off. Take the 2 to the left. It will be 5. That means that 5 divided by 3 is equal to t. So that means that this value here of t1 is just 5/3. Right? So we've got the first critical value. Now we need to get the second one. So to get the second one, again, look at your graph. What direction are the graphs going in at this point of intersection? So the green graph, which is NB, is going downwards. So it's going to be positive on this side, as we can see. Sorry, it's going downwards, so it's going to be negative. Apologies. It's going downwards, so it's going to be negative like this, going downwards. And then the yellow graph is going upwards, isn't it? So we need it to be positive. So we need a combination for the NA graph to be a positive gradient and the NB graph to be a negative gradient. So that would mean, if I look at this here, this is my starting point. I would need NA to be positive. So therefore, I'm going to do equation 2 here. I'm going to, instead of writing a minus, I'm going to put positive. So positive t minus 3 plus 4 is equal to 8, and then minus, and then remember, we need the green graph to be going down. It's negative. So we need the gradient to be negative. So I'm going to make this here, I'm just going to make this positive because that would be minus and plus will make a minus. So I'm going to put positive and then 2t minus 6 like this. And then now tidying this up, it's going to be t minus 3 plus 4 is equal to 8. And then I've got minus and then 2t minus 6. And then just tidying this up a little bit more will give me a t plus 1 is equal to 8 minus 2t minus minus is plus, so plus 6 here. So therefore we can say that t plus 1 is equal to 14 minus 2t. And then again, to get t, we're going to move the minus 2t over, so it's going to be 3t here. And we're going to take 1 away, it's going to be 13. So therefore, we're going to have t is equal to 13 over 3. So that would be our t2 value, isn't it? So we can say that t1 is 5/3 and t2 is 13/3. So what I'm going to do, let me just write about this t2s and put these here. So now we know that this is 5/3 for this one, and this one here is 13/3 for that one. So we're here. And then remember, the question asked us to find the range of values for which the number of subscribers in A is more than the number of subscribers for B. So we can see that the number of subscribers for A is greater than when it's less than this 5/3, isn't it? Because the yellow graph is above the green graph here. So we could say what I'll do, because it asked for set notation, right? But I'm going to just do it in normal inequalities first. So the first part of that one is going to be where t is less than 5/3, right? The yellow graph is above the green graph for t is less than 5/3. T is less than 5/3. And then and then again, where is the yellow graph above it? In between, the green graph is higher, and then after that, the yellow graph becomes above it again. So it's going to be when it's greater than 13/3. So therefore, your answer in normal inequalities would be t is greater than 13/3 here. But we need this as set notation, so this is not too bad now. So what you're going to do is just going to just put a squiggly bracket here. You're going to say t, and then t is such that t is less than 5/3. This, and then this or you can just replace with a symbol like this, so like that. And then you're gonna do the same thing here. You're gonna say t such that t is greater than 13/3, like this, and that will be your answer for part C. Now, just a quick one. It did say that it was over a 5-year period, isn't it? So technically speaking, maybe you may have to just say, for example, t would have to be between 13/3 and 5 for this one, because technically it's over a 5-year period. So that would be this one here, like this. I think both of it will be off. I think either one will be fine though. And then for this one, remember t was greater than or equal to 0, wasn't it? Right? It said it at the top here. It said it here. So technically, I think you could just say that you get this here. So it's going to be t is between 0 and 5/3. But I think either one would be fine, to be honest. But yeah, I'm sure the mark scheme will let us know. But yeah, that would be our answer for part C. Now part D, again, how much room do I have on another page? Cool. So part D, what does part D say? Let's look. It says state a limitation of the model of state a limitation of the model used for company B. And that would be, let me just put this here. So again, remember the common theme with this question is that you're looking at the graph to help you answer the question, to help you visualize what's going on. So this is the graph here again. And what is an issue with company B? What is a limitation of it? Well, if you look at it, let me just get the question up here. Wow, just do it again here. Just bring this home. Okay, so if you look at this one, you can see that, well, for company B, which is the one going downwards on the end, right? Well, it's just going to keep going down, isn't it? It's going to get to a point where you're going to get to 0, right? And then the the number of subscribers will become negative, which you don't want, right? Which doesn't make sense. Yeah. So that would be an issue. Where does that happen though? So that would be when NB is equal to 0. So that would be 0 is equal to, what was the model? It was 8 minus the modulus of 2t takes 6. And again, it's going downwards. So I need the gradient to be negative. So I'm going to just make this negative here. Going to make this positive, so it's negative. So it becomes 0 is equal to 8 minus 2t minus 6. And that will be 0 is equal to 8 minus 2t plus 6. So that would mean that I've got 2t on this here, then this is equal to 14. T is equal to 7. So basically what happens is that after 7 years, the number of subscribers of company B will be 0. Anything after that, the subscribers will be negative. So you could just say that the model is not valid for t is greater than 7, as number of subscribers becomes negative. And that is it. That is this one done. So that will be question 12 finished. Okay, so question 13 says, find the first 3 terms in ascending powers of x of the binomial expansion of 3 plus x to the negative 2, writing each term in its simplest form for 4 marks. Okay, so this isn't too bad. We're just going to be applying the binomial expansion formula, which I'll just write here. So we're going to have 1 plus ax to the power of n. This is equal to 1 plus n ax plus n and then n minus 1 over 2 factorial and then ax all squared, and then plus n and then n minus 1 and then n take 2 over 3 factorial, and then ax all cubed, and so on and so forth, right? Now we need it to the third term, first 3 terms, so we're going to go up to x squared. So yeah, this isn't too bad. So let's have a look now at what we're dealing with. So we've got 3 plus x all to the -2, right? Now remember, look at the formula, there's a 1 here, so you always need there to be a 1. So what you need to do for this one is you need to factor out that 3 to make it 1. So what I'll do is I'll take out a 3 from both terms. I'll put 1 there, and that'll be a third, wouldn't it? And then this would all be to the power of -2. And then from your index laws, we can see that the 3 can come out with a power of -2. So it becomes 3 to the -2, and then 1 plus a third x all to the -2. And remember, we can see that 3 to the -2 is 1/9, isn't it? So it just becomes 1/9, and then 1 plus a third x to the power of -2. So essentially, you're just going to be using the binomial expansion formula for this expression here, and then timesing it by a 9th when you're finished. So let's go ahead and do that. Now, we can see quite clearly that our ax in this case is going to be a third x, and our n is just equal to -2. So we're just going to be applying this formula. Let me just zoom out so you can see both of it in the same page. Okay, so it's going to be 1 plus a third x to the power of -2 will equal, now plugging this into the formula, 1 plus n, which is -2, ax, which is a third x, and then plus n, which is -2, minus 1, -3, over 2 factorial, and then it will be a third x all squared, and so on and so forth. So we just need up to the third term, so we're going to leave it here. And then tidying this up will give us 1, 2, minus 2 times a third is -2 thirds, so it'll be -2 thirds x. And then when I look here, I've got a -2 and -3, that's positive 6. 6 divided by 2 factorial is just 6 divided by 2, which is just a 3. So I'm going to have a 3 here. And then we're going to multiply by a third x all squared, which is going to be a 9th x squared. So now tidying this up one more time, this will give us 1 minus 2 thirds x, and then 3 times a 9th is just a third, so it'll be plus a third x squared, right? And then now we've got this expansion, right? Remember, we need to multiply by that 1/9 to get the full answer. So you're just going to say, therefore, we have to do 1/9 multiplied by all of that. So 1 minus 2 thirds x plus a third x squared. And then that will just give you, for your final answer, all right, like this here, 3 plus, all right, therefore, 3 plus x to the -2 will equal 1/9 times 1 is a 9th. And then 1/9 times -2 thirds will be -2 over 27. So -2 over 27 and an x. And then 1/9 times a third is 1 over 27. So it'll be 1 over 27 x squared. And that will be your answer for part A. So that's fine. That's 4 marks done. That's not too bad. Now part B says, using the answer to part A and using algebraic integration, estimate the value of the integral of 0.2 to 0.4 of 6x over 3 plus x all squared dx, giving your answer to 4 significant figures. Okay, so this isn't too bad. So remember, they've told us that we need to use part A, so there must be some sort of connection or relationship. So let me just screenshot this, and then let's just get what we have figured out in part A, because we're obviously going to need it. So let me just make this a bit smaller so it fits onto the page. And then from part A, we've worked out, what's happened here? So I'm back on the question. Let me just go back to the question that we're on. Okay. Yeah, so we're here. Apologies. So yeah, we know that 3 plus x to the -2 is equal to, what was it again? It was 1 over 9 minus 2 over 27. 1 over 9 minus 2 over 27x, and then plus 1 over 27x squared. Let me just double check that. Yeah, that's fine. And obviously, algebraically, we know that 3 plus x to the -2, right here, 3 plus x to the -2 is just the same as 1 over 3 plus x all squared, isn't it? So I can just replace this. I'm going to rub this out. I'm going to rub this out, and I'm going to write this as 1 over 3 plus x all squared. Now remember, we need to integrate this expression here, and it has a 6x on the numerator, right? Now if I write 6x over 3 plus x, just underneath. Well, what is the connection? How do I go from the one on top to the one on the bottom? The only difference is that the numerator has changed from a 1 to a 6x, meaning that I've just multiplied by 6x here. So what I need to do is multiply this by 6x, isn't it? So we could just say that this must be equal to then 6x multiplied by everything inside. So I'll try this like this. So it'll be 6x multiplied by 1 over 9, and then minus 2 over 27x plus 1 over 27x squared. And we just need to tidy this up, and then this is what we would be integrating. So we've got 6x times a ninth. That will be 2/3. So it'll be 2/3 x. I don't need this bracket, to be fair. And then the next term is going to be 6x times that there. What I'll do is I'll just put the constants into my calculator just so I don't make any mistakes. So I'm going to do a 6 multiplied by negative 2 over 27. And that will give me minus 4/9. So it'll be minus 4/9 for the constant. And I've got an x and an x. That'll make me an x squared. This. And then the last one will be it will be 6 times 1 over 27, wouldn't it? Over 27, and this gives me 2 over 9. So it'll be plus 2 over 9 for the constant, and then x and x squared will make an x cubed. So we know that 6x over 3 plus x all squared is equal to this on the right. So if I need to integrate this, it means I need to integrate this, don't I? And then applying those limits of 0.2 and 0.4 means I have to just do it here. So we're just integrating this on the right hand side and then going to plug in our limits to evaluate and see what we get. So let's go ahead and do that. So integrating this, let's do it term by term. So we're going to have 2/3 x. If I integrate that, that will be x squared over 2. The 2's will cancel. This is a third x squared. You could just double check that. And then we've got minus, and then we've got the 4 over 9. Add 1 to that power will be 3. Divided by the new power, it would be over 3. So it would be 4 over 9 times 3, which is 27, isn't it? So it would be 4 over 27 and then x cubed. And then plus the last one, add 1 to that power will give me a 4. Divide by the new power of 4. So I have 9 times 4 on the bottom, which is 36. 2 over 36 is 1 over 18. So it'll be 1 over 18 x to the power of 4. And yeah, that should be fine. Let me just double check a couple of times. Let me do this one again. X cubed over 3. 3 over 3. Yeah, that's fine. 27. Yeah, that's perfect. This is fine. So now we're just going to plug this in and then see what we get. So for the upper limit, it's going to be 1/3. And it's going to be 0.4 all squared minus 4 over 27 and then 0.4 all cubed plus 1 over 18 and then 0.4 all to the power of 4. And then we're going to take away, and it's going to be 1/3 0.2 squared minus 4 over 27 and then 0.2 cubed plus 1 over 18 and then 0.2 all to the power of 4. And what I'll do is I'll just work this out, take them away and see what we get. So I'll do this here. So get my calculator. For this upper limit, it's going to be a 1/3, 1/3, and then 0.4, 0.4 all squared minus 4 over 27. And then it's going to be 0.4 all cubed. And then it's going to be plus 1 over 18. Plus 1 over 18. And then 0.4 all to the power of 4. And this gives me this number here. So 764 over 16,875. 764 over 16,875. And then minus, and then I'm going to do this one here and see what it gives me. So I'm just going to change all of the numbers to 0.2s and I want that for the lower limit. So it's going to be 0.2, 0.2 here, and then this is going to be 0.2 here, and this one's going to be 0.2 here. And then this will give me this number here. So 413 over that denominator, which is 33750, 33750. So I'm just going to take those away and then see what we get. So it will be 7. I've already got that stored, so I'm just going to do this number take away answer. So 764 over 16875 take away answer will give me this number here, 223 over 6750, which is that. And then it said to 4 significant figures, didn't it? Did it say 4 significant figures? Yes, it did. So that would be equal to 0 point, and then what was that? 0.0330. That would be a 4. So it would be 0.03304, wouldn't it? To 4 significant figures. And yeah, that is fine. That's perfect. So that is part B done. Now, part C says find using algebraic integration the exact value of the integral of 0 0.2 0 0.4 of the same thing, right? Give an answer in the form a, l, and b plus c, where a, b, and c are constants to be found. Okay, so in part B, we found an estimate for the integral, right? Because obviously we used the binomial expansion up until a certain amount of terms. For part C, we want the actual exact value of this integral here. Now, whenever I'm integrating, remember what I've always said, it's a fraction. Just check to see what you've got here. Now, on the denominator, I have some function with a power, right? Now, this is a common theme with integration by substitution, and I'll just show you what I mean. So, a very common case would be, for example, you have maybe, I don't know, you'd have x on the top and then divided by, I don't know, root x plus 1 dx, right? This is a common case where you would make the expression inside the square root equal to x plus 1, and then you would differentiate and so on and so forth. Now, this works with roots, but also works with powers too. So what I would do is I would use substitution, and I would set u equal to 3 plus x. So what I'll do is let me get this here and then put this here. How much room do I have? Okay, I've got enough page. I'll do it here. That's great. Okay, so we're integrating this, and we're going to use substitution for the reasons I just stated. So yeah, in that case, then, remember with use substitution, you have an integral in terms of x, and you use the substitution u to get your integral in terms of x into terms of u. And then that will be something that will be much more easier to integrate. So let's go ahead and see what we get. So I've got the integral of 6x and over 3 plus x all squared dx, right? And don't forget the limits, because those are going to need to change. Now, if I set u equal to 3 plus x, right, then straight away, then that means that for me, I like to update the integral. This will become 6x over 3 plus x is u, so this will be u squared, and then dx, right? Okay, got this here. And then now, well, 6x on the numerator, right? How can I get that 6x? Well, from here, I could say that, well, x is equal to u take 3. And then if I want 6, I'm just going to times both sides by 6. It'll be 6u minus 18. And then again, I could update this and say that this just becomes integral over 0.2, 0.4. And then it becomes 6u minus 18 over u squared, and then dx, right? So we need to get rid of that dx. Now remember how to get rid of dx. You just need to differentiate your expression for u. So we have u is equal to 3 plus x. And that means that du over dx is just equal to 3 goes to 0, x goes to 1, implying that du is equal to dx. So that means we could finish off, well, not fully finish off, but in terms of the variables, become 6u minus 18 over u squared, and we've now figured out that du is equal to dx, so I can write this as du. And then now we've got these limits 0.2 and 0.4. Remember, these limits here were in terms of x, isn't it? X equals 0.4 and x equals 0.2. We need to write these in terms of u, which isn't too bad, because we know that u is equal to 3 plus x. So if I say x is equal to 0.4, then that would just mean that u is equal to 3 plus 0.4, which is just 3.4. And if I say x is equal to 0.2, that will mean that u is equal to 3 plus 0.2, which is just 3.2. So therefore, our limits of integration in terms of u will be 3.4 on the top and then 3.2 on the bottom. And we're integrating 6u minus 18 over u squared du. So we've now transformed our integral into an integral in terms of u. So now we can go ahead and see what we've got here. Now, when I look at this, I've got 6u minus 18 over u squared. Always attempt to separate them when you see something like this here. So what will happen is that this will just become 3.4, 3.2. And then this will become 6u over u squared, minus 18 over u squared, like this, and then du. Now, if I tidy this up, well, then this will just become 3.4, 3.2, and then it will become 6 over u, 6 over u minus, and that will be 18u to the minus 2. And then now we can just go ahead and integrate these. Let me just double check if I've got room. Yeah, I've got one more page. Perfect. So let's go ahead and do this and do it on the last page. So here, I'll do it here and then I'll put on the last page. This will become, if I integrate 6 over u, remember, recognize this is just the integral of 1 over x, isn't it? Which is ln x. So this would be 6 ln u, isn't it? Right? So it'll be 6 ln u, and don't forget your modulus signs, and then minus, and then I need to integrate this. If I add 1 to that power, it will become -1 divided by the new power. It will be over -1. Minus 18 over -1, it will be plus 18. So it'll be plus 18 here, and then it'll be u to the minus 1. And we're integrating between 3.2 and 3.4. So now we just need to evaluate and put this in. So let me just copy this and put this on the last page, if it lets me. Oops, will it let me? Yes, it will. Okay, copy this, put this on the last page. And we're nearly done. Let's get the show that as well. What was the show that? We just give it in the form a, l, and b, which is great because we've got a natural logarithm anyway. So plugging this in now will give us, let's do the upper limit. So it will be 6 ln 3.4 and then plus 18 and then u to the 3.4, sorry, to the minus 1, like this here. And then we're going to minus that 6 ln of 3.2 and then plus 18 and then whoops, and then we're going to have 3.2 to the minus 1, and then like this. So we need it in the form a, ln, b plus c. So we need the ln's together and the constants together. Right now, absolute values I'm going to remove because they're both positive terms anyway. So I'm just going to write like this here. So I'm just going to write like this here, like this, and then I'm going to write like this here. Oops. Let's go write like this. Okay, so let us tidy up. So we've got to, if I tidy this up here, I'm going to have 6 ln 3.4. And then what I'll do is, let me just put this all into my calculator actually, why not? So 18 times 3.4 to the minus 1 is equal to 90 over 17. So that there is 90 over 17. 90 over 17, and then minus the 6 ln, and then 3.2. And then minus, and then that term there, I'll change this to 3.2 and see what we get there. So we're going to have this here, and that gives us 45 over 8. So I'm taking away 45 over 8. And then what we can do is tidy this up here. So what I'll do is I'll do these constant terms, this here. I'll work out what this is. So that would be 90 over 17 minus 45 over 8. And this will give me minus 45 over 136. So minus 45 over 136. And then 6 ln 3.4 minus that. So if I take out a 6 here, I'll just be doing the ln of 3.4. Take the ln of 3.2. If I take out the 6 from both of these terms here, so I'll just do this here. I'm taking out this 6 here, putting it on the outside, and that will leave me with these terms here inside, isn't it? So that becomes there. And then now I just need to work that out. Now remember, from your log laws, if I subtract two logs with the same base, I can just divide them. So it's just going to be 6 ln of 3.4 over 3.2 minus 45 over 136. And then I'll just work out what 3.4 over 3.2 is. So that would be 3.4 over 3.2. This is equal to 17 over 16. So therefore we have 6 ln 17 over 16 minus 45 over 136. And I think that is fine because that was the form that they wanted it in. A ln b plus c, yeah, that's fine. So that means that we can say that a is equal to 6, b is equal to 17 over 16, and c is equal to negative 45 over 136. And that is our final answer. And that will give us 5 marks, and that is 13 finished. Okay, so question 14 says, show that the equation 2 tan theta multiplied by 8 cos theta plus 23 sine squared theta is equal to 8 sine 2 theta multiplied by 1 plus tan squared theta may be written as sine 2 theta multiplied by a cos squared theta plus b cos theta plus c is equal to 0, where a, b, and c are constants to be found for 3 marks. Okay, so this isn't too bad. So remember, this is a typical question where you've got to use your trig identities, right? So they give you some sort of expression in terms of maybe loads of trig expressions, and then you have to just simplify it into a few, right? And this requires you to have a very good knowledge of your trig identity. So I always say to my students, make sure you memorize your trig identities very, very well, because although they're in the formula booklet, when you're faced with questions such as these, you need your identities to flow, right? It's not going to flow if you don't know them off by heart. But anyways, let's make a start. So we've got this expression here, and we need to show that it's equal to this expression here. Now, when I'm doing a show that question, especially dealing with trig, I like to look at what expressions I have in the final answer, right? Now, I can see that I've got sine 2 theta here, and I've got cosines. So for me, when I look at that, because the show that wants me to have it in terms of sine 2 thetas and cosines, I will try and get everything that I have here in terms of sine 2 thetas and cosines, right? So any identities that I can to rewrite in terms of cosine, I will definitely do. So let's write out the question. So we've got 2 tan theta, 2 tan theta, and then 8 cos theta plus 23 sine squared theta is equal to 8 sine 2 theta, and then 1 plus tan squared theta, like this here. Like this. Okay, now straight away, when I look at this expression here, the sine 2 theta I'm going to keep, right? Because I know that I have sine 2 thetas in my show that. Now, I can see that I've got a 1 plus tan squared theta. And straight away, you should recognize that that is just sec squared theta, isn't it? Right? This is just an identity. And then as well as that, sec squared theta is also equal to 1 over cos squared, isn't it? So therefore, I can rewrite this 1 plus tan squared theta as sec squared, but sec squared is the same as 1 over cosine. So I'm going to write this as 1 over cos squared. So therefore, the right hand side will just be 8 sine 2 theta. And then I'm going to times this by 1 over cos squared. And that's what I want to do, because the show that has it in terms of cosine. So I want to get as many cosines as possible. Now, let me just move this let me move this here out of the way. And then if I look at the left-hand side, well, I can see that I've got a tan theta here, which I know is sine over cosine. So I'm going to say this is just 2 times sine over cosine, like this. And then multiplied by 8 cos theta, and then plus, and then 23. And then when I look inside here, I've got sine squared theta. And from our identity, sine squared plus cos squared is 1. Sine squared theta plus cos squared theta is equal to 1. That tells us that sine squared theta is just equal to 1 minus cos squared, isn't it? So therefore, I can replace that sine squared theta with 1 minus cos squared. And that's what I want to do, because remember, we want it all in terms of cosines where possible, right? So I get this here, and then we close this bracket. So we've got this here. Let me just let me just make this better. Yeah. So we've got this here. Now, let's look at our show that again. We need it in terms of cosines. Now, for me, when I look at this, I know that I need the sine 2 theta to stay there, so I'm not going to change this. But that 1 over cos squared, I'm going to multiply on both sides, right? Because that will simplify with the cosines here, wouldn't it? The cosine on the bottom here. So if I multiply both sides by cos squared to cancel out that 1 over cos squared like this, right? Then it will just be 2 times sine theta over cos theta multiplied by cos squared theta. And then in the bracket, I'll have 8 cos theta plus, expand that bracket now, 23 minus 23 cos squared theta, like this here. And then this is equal to 8 sine 2 theta, isn't it? Because that will cancel with that. So I get this here. And then now, tidying up the left-hand side, I've got a cos theta on the bottom and I've got 2 on the top. So one of them is going to cancel. So I'll just leave with 2 sine theta, cos theta, and multiply by that bracket there, cos theta plus 23 minus 23 cos squared theta is equal to 8 sine 2 theta. Now, again, remember, having a good knowledge of your trig identities is very important because 2 sine theta cos theta is just sine 2 theta, isn't it? So sine 2 theta is equal to 2 sine theta cos theta. That's just one of your double angle identities. So that means I can just replace this here with sine 2 theta. So I get sine 2 theta, then I have 8 cos theta plus 23 minus 23 cos squared theta. And then this is equal to 8 sine 2 theta. Okay, so we are here. Now let's get the show that again, because you should always get your show that at hand so you can just compare and contrast with what you have and what you need to get to. So let me just put this here. So this is what we need to get to, right? So comparing with what we've got so far, well, this is good progress because we've got sine 2 thetas and cosines, which is what we wanted. But on in the show that the right hand side is 0. So for me, naturally, that tells me I need to move that 8 sine 2 theta over to the left hand side. So that will give me sine 2 theta and then 8 cos theta and then plus 23 minus 23 cos squared theta. And then this takeaway is going to be minus 8 sine 2 theta like this, and this is equal to 0. So this is good progress. And then now again, looking at what they've got, they haven't got one term take away another. They've just got a sine 2 theta multiplied by an expression here. So we just need two expressions multiplied together. The only way we can do that from what we've got is by factorizing, right? And we can do that because we can take out a factor of sine 2 theta from both terms. So if I do this, this will give me sine 2 theta on the outside, and then on the inside, right, I will have this expression here, right, and then I'll take away that 8 there. So therefore it will just be 8 cos theta plus 23 minus 23 cos squared theta, and I'm going to take away that 8, and then now tidying this up will give me sine 2 theta, and then since they want cos squared theta first, I'm going to just reorder it. So I'll have minus 23 cos squared theta, and then I'll have the plus 8 cos theta, and then I've got 23 take away 8, which is positive 15. So I get this here, and this is equal to 0. So we're pretty much done, right? Because we've got it in the format. We've got sine 2 theta at the front, and we've got a quadratic in terms of cos in the bracket. So this is fine. Now, I'm sure in the mark scheme, they probably have the cos squared term to be positive. So I'll just do that too. But this will definitely give you 3 marks. This is definitely fine. But just to do that, so what you can do is if I take out a factor of -1 to get the cos squared term to be positive, I have -1 here, and then it will be 23 cos squared theta, and then these will have to flip signs, wouldn't it? So it'll be minus 8 cos theta, and then it will be minus 15, and then this is equal to 0. And then now, if you think about it here, this here is a factor, so is this one. -1 is a factor, and so is this one. So technically, what you can do is divide by that factor of -1 on both sides. Now, when I do this on the left-hand side, those -1s will cancel. So I'll just be left with sine 2 theta, and then it will be 23 cos squared theta minus 8 cos theta minus 15, and then 0 divided by -1 is 0. So we get this here. So this is probably the form that they've got in the mark scheme. But this here will give you 3 marks, and so will this one. These are perfectly valid, both of these here. So that is part A done, and that's 3 marks in the bag. So let's go to part B. Part B says, hence solve for x between 360 and 540, 2 tan x plus 8 cos x plus 23 sine squared x is equal to 8 sine 2x plus 1 tan squared x, where x is an element of the rules and x is never equal to 450 degrees for 4 marks. Okay, so this is a typical question, right? In part A, they give you some sort of trigonometric expression, and they say that show that this may be written as something else, and then in part B, it says hence solve that same expression. Now, just looking at what they've given us in part B, right? This here, this is exactly the same as the initial expression in part A. The only difference here is that we've got thetas in the initial expression, like this, and they've got x's here. So the x's, so the thetas have been replaced with x's, haven't they? So I would just say here that this here, I'm just going to say theta has been replaced with x, isn't it? Yeah, it's the exact same equation. Now, if it's the exact same equation, it means that the show that we did we can use to solve it, right? Because that's the whole point of a show that maybe you can write something that's a bit confusing or difficult into a simpler form. So if I need to solve this in part B, it will be the exact same as solving this show that in part A. But instead of writing thetas here, I'm going to replace it with x's, aren't I? So what I'm going to do for part B is let me just copy the equation, but let me take off the yellow highlighters before I do that. So take these off. So I'm going to just copy all of this part B, so I don't need to keep going up and down. And I'll do it on the next page here. So this will be here. And then let me just minimize it so it fits onto the page. So this is what we need to solve, right? But remember, in part A, we showed that that expression is equal to this expression here. But instead of writing thetas, right, I'll write x's. And to be fair, this is in terms of A, B, and C, but I've got this here. So I'm going to just use this one here. So let me just copy this, if it lets me. I'm going to copy this here. And this is the expression we're going to use. So remember, in part A, we showed that the expression in part B is equal to this here. But instead of writing thetas, I'm going to replace those with x's, aren't I? So let me just do that. And then we'll just go ahead and solve it. So let me just replace the thetas. So I'm going to replace this here. I'm going to get rid of this here, like that. I'm going to get rid of this here. And instead of writing thetas, I'm just going to put x's there instead. So sine 2x here, cos squared x here, and then cos x here. And then this is what we need to solve, right? And yeah, so let's go ahead and do this and see how we get on. So we need to solve this equal to 0, right? Now we've got sine 2x multiplied by this bracket here. Whenever two things are multiplied together and they give you 0 as your outcome, it just means that each of them individually must be equal to 0. So I can say that sine 2x is equal to 0 here. And then I can say that 23, all right, or, and then 23 cos squared x minus 8 cos x minus 15 is equal to 0. Okay, so let's start with sine 2x is equal to 0. Now remember the range is from 360 to 540, isn't it? So if I've got a 2x here, then I will just double the range, wouldn't I? It'll be 720 here, and then this will be 2x here, and then this will be 1080, wouldn't it? So I'm just going to be looking for values between 720 and 1080 and halving them after. So this is just sine 2x equal to 0. So what does the graph of sine x look like? It's just going to be like this. So this tells me that we get 0 here, 180, and then 360, and so on and so forth. So if I wanted to solve this equation here, it will be 2x is equal to, you'd get sine inverse of 0, which will give you 0, and then it repeats after 180, doesn't it, as you can see from the graph, and then 360, and then so on and so forth. The next one would be 200 is be 540, and then it would be 720, and then 900, and then 1080, isn't it? Okay, so and so on and so forth. Keep going. And remember, we need it between 720 and 1080. So I'm just going to look here, right? So that means then I'm just going to be solving those equations, right? So that means that if I have x here, x will equal, if I divide this by 2, then I have to divide these terms by 2 as well. So it'll be 360, and then it will be 900 over 2 is 450, and then it'll be 540, isn't it? So these are the three solutions here for x when sine 2x is equal to 0 between 360 and 540, right? Now remember, be very careful. They told us that x is never equal to 450, so we can't include this 450 term. So you can just say, since x is never equal to 450, from here you could just say that x is just equal to 360 and 540. And that will give you the values of x for that equation, sine 2x is equal to 0, between our range. And then now we need to solve the quadratic, don't we? And again, the range is between 360 and 540, but because they're x's, I'm just going to keep the range the same. I'm not going to times by 2 with what I did here, because that was a 2x there. So we just need to solve that. So let me just get this here, and then put this here. Just copy this like that, and then put this here. Okay. So this is a quadratic, isn't it? So what I'm going to do is I'm just going to put this into my quadratic calculator to give me the values of cos x and then solve those individually. So I'll get my calculator. So I get this here, and then I'll just go to menu, and then go to equation solver, and then polynomial degree 2, and then plug in the coefficients of 23, -8, and -15. and then this gives me a 1. So the first answer is going to be cos x is equal to 1. And then the second solution, I'm just going to click equals again. Whoops. Equals again. This will give me a minus 15 over 23. So I've got to solve these now. Okay, so solving cos x is equal to 1. Now, this is just a standard one. The cosine graph looks like this. Starts at 1, goes down, and goes to 1 again. So that just tells me I've got 1 here. And then remember, the range is between a 360 and a 540. So the cosine graph hits 1 again at 360. So yeah, you'd have x is equal to 360 here for one of the answers. And then the next one would just be 360 after that, isn't it? Which would be at 720, and then so on and so forth. However, though, remember the range is between the range is between 360 and 540. So the only valid answer here would be the 360. Yeah. So from this one, x is equal to 360, but we've already got that there anyway. So we can just say that x is equal to 360, 540 so far, right? So we got 360 again, but we already had it here. So this stays the same. Now that is done. Now we need to solve this one here. So we've got cos x is equal to minus 15 over 23. I'm just going to do the cos inverse to figure out what that is. So I'd have a cos inverse of negative 15 over 23 is equal to that number there. So I'm going to say x is equal to 130 point, what was it? 705, blah, 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 blah. Now remember, to solve this, you can just use the cast method. You can just sketch the diagram however you want. You can just memorize the rules for when cosine repeats. So for this one, we've got x equal to 113. Now to get the next solution, remember the cosine repeats. Can you see here? Symmetry, right? It's going to be 360 minus the principal value. So the next answer would be 360 minus x. That will be where the next solution would be. So I'm going to do 360 minus x. So 360 minus the answer would give me this here, which would give me 229.294 blah blah blah. 0.294 blah blah blah. Now we've got these here, so I'm going to just say that x is equal to 130.705, and then the next solution is 229.294. And then once you've got these two values, you can just keep adding 360 to see where the next one will be. So add 360 to give me that one, add 360 to give me that one. So I'll do that. So the first one, let me go back up here, got this here. If I do answer plus 360 to that one, that will give me 490.705. So the next one will be 490.705, blah, blah, blah. And then the one after that, let me just make a bit of room, nearly done. I'll just remove all of this here. So there's a bit of room. And then the next one would be when this 229 number is added, when I add 360 to that. So I'll get that there. I've got it here, click equals to get it stored. Whoops. Or, I'll just write out again to be fair. 229.294 blah 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 plus the 360 will give me 589 anyway, which is outside of our range, so we don't even need it, but let's just put it in there anyway. 589.294 blah blah blah, which is outside of the range. Remember, the range was between 360 and 540. So what values are between 360 and 540 here? It's just going to be this value right here. It's the only value between 360 and 540 out of these values here. So you could just say, therefore, your x is equal to 490.705. Now, was there any degree of accuracy? No, there wasn't. There wasn't. So I'll just give it to three significant figures, which will be to the nearest whole number, isn't it? So therefore, I could just say that you've got 491 degrees here. And that will be all of our solutions for all of these equations here. So therefore, to finish off, you're just going to put all of your answers in. So you could say x is equal to 360 and 540 from there. And then this one is 491. So this here will give us our 4 marks. And you can write this in order of size if you want. But yeah, that is pretty much it for that. And that is question 14 finished. Okay, so question 15 says, a student attempts to answer the following question. Given that x is an obtuse angle, use algebra to prove by contradiction that sine x minus cos x is greater than or equal to 1. The student starts the proof with Assume that sine x minus cos x is less than 1 when x is an obtuse angle, and then they've squared both sides. Sine x minus cos x all squared is less than 1, and this implies blah, blah, blah. The start of the student's proof is reprinted below. Complete the proof. Okay, and this is 3 marks. Okay, so this is not too bad. So this is just proof by contradiction. Now remember, when you're dealing with proof by contradiction, they give you some statement, and you have to assume the opposite of this statement. And with the assumption of the opposite, you use logical steps or algebra to arrive at some contradiction which contradicts your assumption. And with that contradiction, that will prove the original statement. So what the student's done first is he's assumed the opposite, right? Or they've assumed the opposite, that sin x minus cos x has to be less than 1, right? Because the opposite of greater than or equal to 1 would be less than 1. So he's attempted to do that first, and then he squared both sides. So yeah, let's complete the proof. Now, if they've squared both sides, let's go ahead and see what that will give us. So I'll have sin x. Hold on, let me just make this a bit thinner. I would have sin x minus cos x, and then sin x minus cos x again. And this will be less than 1. Now, if I expand this, then I'll get sine and a sine will make a sine squared x, and then I'll have a sine minus a cos x. That will give us a minus sine x cos x. And then I have the exact same thing here. And then I will have, oops, let me just get rid of that C there. And then the last term will be minus cos times another minus cos. That will be a positive cos squared x, isn't it? And this is less than 1. And then tidying this up, this will give us a sine squared x minus 2 sine x cos x. And then plus cos squared x. And this is less than 1. Now, when I look at here, remember, this is trig. Look to see if you can see any identities, right? And the first thing I can see is that I've got sine squared x and the cos squared x. We know that sine squared plus cos squared is just 1, isn't it? So when I add these together, it'll give me 1, right? So I can just simplify the two terms in yellow, sine squared plus cos squared, to just give me 1. So I'll just have 1 minus 2 sine x cos x, and this is still less than 1. Like this. Let me just tidy up a little bit more actually. So let me just write it again. So sine x and then cosine x, and then this is less than 1. So essentially this sine squared plus cos squared x is the same as this one here. They're the exact same thing. And now if we're here, we can just take 1 away from both sides. So I'll get minus 2 sine x cos x is less than 0. Now, I'm going to tidy this up a bit more. I'm going to divide both sides by -2. Now, remember, when you divide or multiply a negative number with an inequality, the inequality will flip, wouldn't it? So this will be greater than 0. And then I'll just have sine x cos x here. So we've arrived here, right? We've got that sine x cos x is greater than 0. And this is when we assumed that sine x minus cos x was less than 1, which was the opposite of the statement. Now, what we need to do is just analyze this expression here and see if there's any contradictions with the original statement, right? Remember, x was an obtuse angle, right? So what I would do is have a look at what I've got here and just check the signs of sine and cosine when x is obtuse. So what I'll do is I'm just going to say when x is obtuse, remember that's just between 90 and 180, isn't it? So if I draw the sine graph, so sine x will just look like this. Starts from 0, goes up, goes like that. Now between 90 and 180, when x is obtuse, right, we can see quite clearly that the graph is above the x-axis, right? So we can say for sure that sine x is positive, like this. And then when x is obtuse for cosine, let's draw the graph here. It's going to be like this, isn't it? And then we can see between 90 and 180, right? The graph is underneath the x-axis, isn't it? Right here. So we could say from here that cos x is negative. It's less than 0, right? So this is the signs. These are the signs of sine and cosine when x is obtuse. So what I can do is with this here, I'm going to write here, this is the fact of the matter, right? This is the fact right here. Now, if I use those, right, well, that means that sine x, cos x, right, will just be equal to, well, sine x is positive, so I'm going to change this to a positive sign, and I'm going to multiply by cos x, which I know is negative, which is going to be a negative sign like this. So I have a plus times a minus, which makes a negative, which is less than 0. So I'm going to say this implies that sine x cos x is negative, right? Now, this is a contradiction to this statement here, isn't it? This is a contradiction because with the assumption that we had, we got to this expression here, sine x cos x is greater than 0. This contradicts this fact here, right? So you're just going to say, so you're just going to go to the next page, you're going to say that sine x cos x is less than 0. Or you know what, actually write in words just so it's very clear. So is negative, right? Since sine x is greater than 0 and cos x is less than 0, right? Now this is a contradiction, or I should say this contradicts sine x cos x is greater than 0, right? Which is exactly what we got here when we assumed that sine x minus cos x is less than 1, right? So since we've got a contradiction here, we could just say that the original statement has to be true. So we could just say, therefore, when x is obtuse, must mean that the original statement, which was sine x minus cos x, must be greater than or equal to 1. Sine x minus cos x must be greater than or equal to 1. And that is it. That will give you the 3 marks. And that's question 15 finished, and that's paper 2 finished. So yeah, we made it to the very end. Hi guys, Daniel here. I hope you're doing well. So yeah, we've made it to the end of paper 2, and that concludes the whole of Pure for June 2023. A lot of tricky things in there, but hopefully you found it overall okay. And any maybe misconceptions or any topics you found difficult or questions you found difficult, hopefully you understand them now. And what's left now is to go to paper 3. So that's stats and mechanics. I'll do a separate video for both of them. So one for stats, one for mechanics. And yeah, again, if you found this video helpful, feel free to like, comment, subscribe, share with your friends, anyone that you think will find it helpful too. And yeah, again, thanks for your support. And yeah, I'll see you guys for paper 3. Take care. Bye bye.